Hi everyone, welcome to Go Classes. In this lecture, we will continue our discussion of CFLs, DCFLs, GATE previous year questions. This is part 2 of GATE GATE previous year questions of detection of CFL, DCFL. Okay, so you can see in the previous lecture, in the part 1, we have seen which languages are CFL, which languages are DCFL, all the GATE PYQs. The part 1 you can find on the YouTube. You can search this Go Classes CFL GATE PYQs on the YouTube. You can search. The link I will provide you in the description, also in the pinned comment. Okay. Also on the YouTube you can find the complete lecture of identification of CFLs. Okay, this lecture also you can find on the YouTube. Again, the link I will provide you in the pinned comment, also in the description. On the YouTube, we have uploaded the complete lecture of identification of DCFLs also, deterministic context-free languages identification. So that lecture also you can find on the YouTube. Okay. So the link of all these lectures you can find in the pinned comment. Now let's start GATE PYQs of CFLs and DCFLs. Let's solve this GATE 2022 question. Consider the following languages L1, L2, L3. Which of the following statement is or are false? The question is asking basically which of these is deterministic context free language, which of them is CFL. Okay, so this is the question. Now let's solve it. First, you look at the option this language L1. This is your WW, where W belongs to AB whole star. This is a standard language which is non CFL. We have already seen this in the previous lecture. Okay, in the part 1 of GATE PYQs, we have already seen that this language WW, where W belongs to AB whole star. So this is a non-CFL. This is a very standard language which is non-CFL. Okay, and if you remember, I told you that this WW, this is a special language. This WW, when W is a binary string, so this WW is not a context-free language, but its complement is context-free. Yes or no? In our context-free language detection lecture, identification of CFLs, you can see in this lecture. Okay, identification of CFLs, complete lecture. Okay, so in this lecture we have already seen, if you remember, that this WW, where W is a binary string, this WW is not a context free language because there is a forward matching here. This W you have to match with this W. Okay, so PDA, your PDA cannot do this using the stack memory. We cannot recognize this type of string WW. Okay, but the complement of WW, this is CFL. Okay, so this is a standard language. WW is not CFL, but the complement of WW is a CFL. Okay, so let me tell you here, in this L1 is not CFL, right? Okay, this L1 is not CFL, but remember the complement of L1, that is CFL. The complement of WW, that is CFL. So let's look at the option D. The question is asking which statement is false. Okay, which statement is false? Let's look at the option D. This is saying neither L1 nor its complement is a CFL. So this statement is false, yes or no? Because this statement is saying that L1 is not CFL, also L1 complement is not CFL. So this statement is false because why? What is the reason? Because you know that L1 complement is actually CFL. Okay, yes or no? WW complement, that is actually CFL. Okay, so that is the reason I can say option D is false. The question is asking which statement is false. So definitely option D is one of the answer. Okay, let's see the remaining options. What about this option A? Option A is saying that L1 is not context free, but L2, L3 are DCFL. Okay, so you already know that L1 is not CFL, that we already know. Okay, WW, where W is a binary string, this is not CFL language. What about L2, L3? So let's see the options. So here you can see what is your language L2. This is A power N, B power N, C power M. Okay, so this is DCFL. Yes or no? This is a standard language which is DCFL. Also your L3. This is A power M, B power N, C power N. This is also DCFL. This is also deterministic context free language. Every DCFL is CFL. Okay, so you can see that this L2 is also CFL and this L3 is also CFL. Okay, so what about option A? Option is saying that L1 is not CFL. That is correct. Okay, because L1 is not CFL. Okay, but L2, L3 are DCFL. Yes, this statement is actually true. The question is asking which statement is false. So this option A is not the answer. Okay, yes or no? Because this is not false. Option D is false. So that is the reason, that is one of the answer. Okay. Now let's see the remaining. L1, neither L1 nor L2 is context free. This statement is false because actually L2 is CFL. Yes or no? So this is one of the answer because this option B, this is false. Okay. What about the next? Option C. Option C is saying that L2, L3 and their intersection are all context free. Okay, so we have to find what the intersection of L2, L3. First, let me tell you about L2. So the language L2 is basically A power n, b power n, and c star. Yes or no? Because you can see that m comma n both are greater than equal to 0. Okay, so a power n, b power n, and this number of c, this is basically, this can be anything. Yes or no? There is no relationship between m comma n. You can see we have a power n, b power n, but this number of c has no relationship between number of with number of a. Yes or no? So I can say this is your L2. And what about L3? L3 is basically m comma n greater than equal to 0. There is no relationship between m comma n. So you can see this is a power m, b power n, c power n. So I can write it a star, b power n, c power n. This is what I can write. Yes or no? Now you can easily see that this L2, this is basically DCFL language. Every DCFL language is CFL language. Okay, so this a power n, b power n, c star, this is basically DCFL. Why this is DCFL? Because you can create DPDA for this. What you will do? You will push all the a's. For every a you will push one a. For every b you will pop one a, and then you can see when, okay, at this moment when the c will come, then your top of the stack must have z. Okay, then what we will do, then we will go to final state and we will read all the c. Yes or no? So basically we will skip all the c in the final state. So very simple. So there is DPDA for this language. Similarly for L3 also there is DPDA. Okay, we will ignore all the a. Okay, all the a we will ignore. Then for every b we will push one b, and for every c we will pop one b. Yes or no? So you can see this is also DCFL. For this language also we can create DPDA. For this language also we can create DPDA. So they are DCFL. Every DCFL is CFL. Okay, so you can see this is also DCFL, and every DCFL is a CFL. Okay, now what about their intersection? Intersection means what? Remember L2 intersection L3. Intersection means common. Okay, this means intersection, and intersection simply means common strings. Okay, common elements. So what are the common strings in L2 comma L3? You can notice one thing, that in L2 number of b is same as number of a. Yes or no? In L2 the number of b, that is same as number of a, and in L3 number of b is same as number of c. Okay, notice one thing, in L2 also you have a is followed by b is followed by c. Yes or no? So the template of L2, that is a followed by b followed by c, and the template of L3 is also the same, a followed by b followed by c. Okay, so the template of L2 L3, that is after a b are coming, after b c are coming. Okay, but you can see in L2 the number of b is equal to number of a, and in L3 number of b is equal to number of c. So the common strings, remember the common strings will be like this: a, b, c. These will be the common strings where after a b will come, after b c will come. Yes or no? But notice one thing here, if this is the common string, then this should belong to L2 also. Yes or no? Because this is a common string, so this must belong to L2. And if this string belongs to L2, then number of a should be equal to number of b. Yes or no? So number of a should be equal to number of b. And remember, because these are the common strings, okay, this is a common string, so this belongs to L3 also. This belongs to L3 also. In L3, remember, number of b equal to number of c. So you can see number of b should be equal to number of c. So we will get a power n, b power n, c power n. Okay, where you can see n is greater than equal to 0. So finally, I can say here you can easily see that L2 intersection L3, that will be a power n, b power n, c power n, where n is greater than equal to 0. This language, this is a standard, not CFL language. Yes or no? This is a standard language which is not CFL. It is not context free language. Why this is not context free language? Because here you can see we need to match number of a with number of b and number of b with number of c. So you can notice what your PDA will do. If you assume this is CFL, if you assume there is a PDA, then what your PDA will do? Your PDA will push number of a in the stack. Okay, so your PDA will push all the a's in the stack. Then for every b, we will pop one a because we need to match number of a with number of b. So what we will do? For every b, we will pop one a. Now you can notice when the c's will come, at this moment our stack does not have any a, our stack does not have any b. Yes or no? Basically from the stack all the a comma b's, they are basically gone. Now you can see there is nothing remaining to match with c's. Yes or no? Okay, so that is the reason I can say no PDA can recognize this language. This language we have seen many times in the previous part also we have seen, also in our CFL identification lecture also we have seen why this language is not CFL. This is a standard example. This is a standard language which is not context free. Okay, so you can see L2 intersection L3, that is not CFL. So this option C is saying that L2, L3 and their intersection are all context free. This statement is false. Why this statement is false? Because L2 intersection L3, this is not, this language will be a power n, b power n, c power n, and which is not CFL. Okay, which is not CFL. Is this clear? Because first you find what is the intersection. The intersection will be a power n, b power n, c power n, and that is the standard language which is a non-CFL. So this option C, this is also false. So the question is asking which statement is false. So this also will be the answer. So remember, for this question, the answer will be, the answer will be option B, C, D. These will be the answer. Okay, is this point clear? One more thing, remember, what the, if the question is asking, let's assume L2 complement L3 complement, then what will happen? If the question asks you what is L3 complement L2 complement, then what will be the answer? I told you that DCFL complement, the complement of a DCFL is always DCFL. Yes or no? Okay, the complement of DCFL is always a DCFL. So remember, if you find L2 complement, that also will be DCFL, because L2 is DCFL, so its complement also will be DCFL, and L3 is DCFL, so its complement also will be DCFL. Okay, is this clear? Very simple. So DCFL complement is DCFL. That is the reason L2 L3 complement, they also will be DCFL. But the question is not asking for L2 L3 complement, so you don't have to worry about it. Okay. Now let's move on. Let's solve this GATE 1988 question. What is the type of language L where L is a power n, b power n, where n is from 0 to 327th prime number? So tell me what is the answer? Here you can easily see this language L is finite language. Yes or no? Okay, because look at this language. This is saying that we have a power n, b power n, this type of strings we have, where what is this? What is this n? This n is basically greater than 0 and less than 327th 327th prime number. 327th prime number. Yes or no? Okay. For example, let's assume in the same question, instead of 327th, let's assume in the question, instead of this, let's assume they say that sixth. Okay, let's assume they say sixth prime number. Then you can notice what is the sixth prime number. Okay, if they say sixth prime number, let's assume, okay, in the question they say sixth prime number, then your language will be what? You can see n is more than 0 and less than sixth prime number. So remember, your n will be what? Your n will be, if I put 1, because n is greater than 0, so I can put 1. Okay, you can see 1 is less than sixth prime number. What is the sixth prime number? Can anyone tell me what is the sixth prime number? Okay, you can see the first prime number is the first prime number, that is 2. The prime numbers are 2, 3, then there is 5, then there is 7, then there is 11, then there is 13. Yes or no? So the sixth prime number, that will be 13. So remember, in this language you will have a power 1, b power 1, a power 2, b power 2, and so on, a power 12, b power 12. Yes or no? This will be your language. I hope you understood. Is this clear? Because the question is saying that n is more than 0 and it is less than sixth prime number. Sixth prime number is 13. Then in that case, n will be more than 0 but less than 13. So I can say this will be your language. You can see this is a finite language. Okay, this is a finite language. And because this is a finite language, every finite language is regular. Okay, every finite language is regular. Every regular language is a DCFL. Every DCFL language is CFL. Every CFL language is CSL. Every CSL language is recursive. Every recursive language is recursive enumerable. Okay, is this clear? So remember this language, the question is asking what is the type of this language. So the answer will be, okay, all these. Basically the answer will be yes, this is regular language. Yes, this is finite language. This is CFL language. This is CSL language. Yes, this is recursive enumerable language. So the answer for this question will be whatever you want. Okay, that will be your answer basically. Yes or no? So very simple. Here you can see that, okay, that this language is finite language. This language is finite language. So the best answer will be finite language. Okay, the question is asking what is the type of this language. So the best answer will be, that this is a finite language, or you can say it is a regular language, because every finite language is regular language. Okay, very simple question. Now remember, in the same question, if there is no range, okay, for example, if they only say that a power n, b power n, where n is greater than 0, means there is no upper bound. Okay, then in that case, what will be the answer? If there is no upper bound on the value of n, then this a power n, b power n, this is a standard non-regular language. Yes or no? So then in that case, what you will say, then you will say that this is a non-regular language, but this is DCFL. This is deterministic context free language, because we can create DPDF for this language. What we will do, we will push for every A, we will push one A, and then for every B, we will pop one A. Yes or no? So very simple. This is a DCFL, but non-regular if there is no upper bound on N. Okay. Now let's move on. Let's all get 2000 question. Let L denote the language generated by the grammar as going to 0 as 0 or double zero. Which of the following is true? The question is asking what is the language basically. This grammar is given to you, and the question is saying that this grammar is generating the language L. So you have to find what is the language L. Then you find which option is correct. Okay. So let me tell you the grammar that is given to you. This grammar is like this, that S is going to 0 as 0 or double zero. Okay, 0 as 0 or double zero. So you tell me which is the language generated by this grammar. You can easily see this is a context free grammar. Yes or no? This is a context free grammar. So one thing is definitely there, that is this is a context free grammar. So language will always be CFL. Okay, yes or no? This is a context free grammar. So definitely you can guarantee that language will be CFL. But remember, this is a context free grammar, so the language will definitely be CFL, but you cannot say that the language will be non regular. The language may be regular, the language may not be regular. You have to find it. Okay. See, many students, what they do, when they see a language, when they see a grammar which is non regular, you can see this grammar is not regular. Yes or no? This grammar is not right linear. This grammar is not left linear. So when many students, when they see that okay, grammar is not regular grammar, then they say that language is also not regular. But that is wrong. Okay, that is wrong. If you remember, I told you in our lectures that a regular grammar will always generate regular language. If you have a regular grammar, if you have a right linear grammar, or if you have a left linear grammar, then language will always be regular language. But if you have a non-regular grammar, then language may or may not be regular. Okay. So here you can easily see what we need to do. We need to find the language. Okay. So tell me what will be the language. What are the strings generated by this grammar? Very simple. I can generate string double zero. This string belongs to the language. What else I can do? This s can go to 0 as 0, and then remember this s I can replace with double zero. So finally what I will get 40. Okay, what more I can do? This s I can replace with 0 as 0, s I can replace with 0 as 0. Now this s I can replace with what? This s I can replace with 0 as 0 again. Okay, 0 as 0 again. Then this s I can replace with what? Already this is there. This s I can replace with double zero. Okay, yes or no? So what I got? I got 60. So you can see I got 0 power 2, I got 0 power 4, I got 0 power 6, and so on. If you do like this, then ultimately if you see the language will be what? The language will be very simple. The language will be 0 power n, or I can say 0 power 2n. Okay, basically 0 power even number where n is greater than equal to 1. Okay, in the language we don't have the empty string. Yes or no? So n will be greater than equal to 1. Very simple. If you want to do the analysis of this grammar, that also you can easily do. Remember, from this s what will happen? Notice this s will basically go to 0 as 0. Okay, then notice one thing, this s will go to 0 as 0. Okay, this s will go to 0 as 0. So it is happening that if you have 0, then there is 0. If you have double 0, then there is double 0. Okay, again if I replace this s with 0 as 0, then what will happen? If I replace with 0 as 0, then you can see if there are 3 0, then there are 3 0. Basically what is happening is this s is going to 0 power n as 0 power n. Okay, yes or no? If you have okay, if you have 1 0, then 1 0. If you have 2 0, then 2 0. 3 0 as 3 0. So similarly n 0 as 0 n 0. Yes or no? So this is what you will get. Now ultimately finally at the end what you can do? Okay, at the end I can replace this with the double zero. Okay, s I can replace with the double zero, or s can directly go to double zero. Yes or no? Or s can directly go to double zero. So finally from here I can see that the language will be what? The language will be, you can easily see the language will be here. If I replace this s with double zero, then finally here this is what I'm getting 0 power n double zero 0 power n. Okay, or double zero, or double zero. Yes or no? Or double zero. So here actually this is basically, in short, okay, this in short I can say that this is basically 0 power 2n. Yes or no? This is 0 power 2n because we have double zero here and we have this double zero, 0 power n, 0 power n. So, okay, in simple words, I can say 0 power 2n. Okay, so finally it will be where n is greater than equal to 1. So very simple. This is the analysis of this grammar. Very easily, you can easily see. Okay, so this is your language. Now, what the question is asking, you can easily see this grammar will generate the language and the language is regular. If you see the language, that is basically 0 power e1, or I can say 0 power 2n where n is greater than equal to 1. Now this language is actually regular. I can write the regular expression for this. What will be the regular expression? The regular expression will be 0 0 whole plus. Okay, yes or no? For this language L, I can easily write the regular expression. Either you can say that 0 0 whole plus, or you can say that regular expression will be like this: 0 0 then 0 0 whole star. Okay, so this is the regular expression. So that is the reason the language is regular. Yes or no? So this language, I can say this language is regular language. Okay, so very simple point, that the language will be regular and the language will be 0 power 2n where n is greater than equal to 1. So option A is wrong because option A is saying 0 plus, but actually we cannot generate triple zero. Yes or no? From this grammar, we cannot generate triple zero. We cannot generate single zero also. If you want, you cannot generate single zero also. So option A is basically gone. Okay. Option B is correct. The language is regular, but it is not 0 plus. Yes, that is correct. Okay, option C is saying it is context free. Language is context free but not regular. This is also false. Option D is saying it is not context free. That is also false. Okay, yes or no? Okay, very simple. One thing you notice one thing. Okay, that is, see, the given grammar is CFG. The given grammar is context free grammar. So the language will always be CFL. Yes or no? Every regular language is also CFL. Okay, you can see that the grammar is already context free grammar. So the language will definitely be CFL. So option D is definitely wrong because the grammar is context free grammar. So the language will definitely be CFL. So option D is definitely wrong. But remember, if you want to find whether the language is regular or not, you have to find the language first, and after finding the language you check is this regular or not. Okay, because very important point I'm telling you, that if you have a regular grammar, then language will definitely be regular, but non-regular grammar may or may not generate regular language. Okay, is this clear? This is a very perfect example. Okay, look at this grammar. This grammar is perfect example that this is not right linear. This is not a right linear grammar. This is not a right linear grammar, because here you can see on the RHS of this production, we have one variable which is not on the extreme RHS, and you can see we have one variable which is not on the extreme LHS. So you can see this is not right linear, because in the right linear grammar what happens, on the RHS we have at most one variable, but that variable must be on the rightmost position. Yes or no? And remember, this grammar is not left linear grammar. Why? Because you can see in the left linear grammar what happens, that on the RHS we have at most one variable and that variable must be on the leftmost position. But here we have, here you can easily see that we have one variable, but that variable is not on the LHS. Yes or no? That variable is not on the leftmost position. So that is the reason this grammar is not left linear. Because this is not right linear, because this is not left linear, so I can say this grammar is not regular grammar. This grammar is not regular grammar. But remember, I told you that no non-regular grammar may generate regular language. Okay, you can see non-regular grammar may or may not generate regular language. Here you can see the language actually will be regular. Here, here you can see the language actually will be regular. Okay, so very simple point. Now let's move on. Let's all get 2004 question. The language A power m, B power n, C power m plus n. What type of language is this? This is a very simple question. The standard language is given to you. This type of language many times we have seen: A power m, B power n, C power m plus n, where m comma n both are greater than equal to 1. This is basically DCFL. This is a deterministic context free language. This language is not regular. Yes or no? Why this language is not regular? Because here you can see that we have to remember how many A's and B's are there so that we can match with number of C. Yes or no? Because remember, number of A plus number of B, this total must be equal to number of C. So here you can see that finite automata cannot do this type of comparison. because here there is this number of A plus number of B that should be equal to number of C. So basically there is a comparison here, and this comparison can bring you infinite possibilities, and that is the reason this language is not regular. So you can see, but this language is DCFL. Okay, we can create DPDA for this language very easily. Many times we have created DPDA for this type of languages. Okay, so remember this is non-regular. This language, this language is non-regular, but this language is DCFL. Okay, so what will be the answer? Every DCFL language is CFL. Okay, so this language is CFL also. So answer will be option B. This is a context free but not regular. Okay, remember every context free language is a context sensitive language. Okay, so actually this option is saying context sensitive but not context free. So this is wrong. This is saying regular. So this is wrong. This is saying type 0. Type 0 means RE language, recursive enumerable language. Yes or no? Type 0, that means recursive enumerable language. So you can see this language is actually context sensitive. Every CFL language is CSL. Every CFL is CSL. Every CSL is RE. Every CSL is recursive, and every recursive is RE. So actually this option is also wrong because this language is CSL. Okay, so answer will be option B. Now let me give you some more explanation here. Actually this language that is given to you, let's create the DPDA. Okay, just for practice sake, let's create the DPDA. A power m, B power n, C power m plus n. Okay, where m comma n, they are basically greater than equal to 1. Okay, this language is actually DCFL. Okay, the reason, let me tell you, because I can write this language. In this language, what will happen? Push comma pop is very clear, because you can see when A's are coming, then we will push A's, and when B's are coming, we will push. Okay, then what we will do? For C's, we will pop. And remember, in the DPDA, I am creating the DPDA. For this language, I am creating the DPDA. In the DPDA, we have and marker symbol. So there is a string and marker symbol. This symbol will tell you that string has ended. String and marker symbol is there in the DPDA. Whenever you create a DPDA for any language, then you can always take this string and marker symbol. This is a special symbol which will tell you that string has ended. Okay, so you can easily see here what we will do. Remember, number of A plus number of B, this total must be equal to number of C. Okay, yes or no? So what we will do, remember, for every A, this is what we can do. For every A, we can push one symbol X. Okay, because remember here, number of A plus number of B, this total must be equal to number of C. So what we can do, for every A we can push 1x, and for every B also we can push 1x. For every B also what we can do, we can push 1x. Okay, and then remember what we will do, for every C we will pop 1x. Okay, we will see, for every C we will pop 1x for every C. For every C. And then remember, when the end marker symbol comes, this symbol will tell you that string has ended. When this end marker symbol comes, then top of the stack must be Z0. Yes or no? This must be the top of the stack, then your string will be accepted, otherwise your string will be rejected. So this is the logic for push comma pop in the DPDA. You can see everything is very clear. A's are coming, you keep pushing. B's are coming, you keep pushing. Okay, yes or no? If A come, push. B come, push. Then when the first C comes, then you start popping. Yes or no? So remember, this first C will tell you that, okay, now start popping. This first C will tell you, this is the first C, and this first C will tell you that now you start popping. So this is the idea. Now let me just quickly create the DPDA. Okay, just for practice sake. Okay, so let me just quickly create. You can see in the DPDA, this is what will happen. Remember, after A, B should come. Okay, after B, A cannot come. After A, B should come, and after B, A cannot come. So remember what we will do here. This is the push state. In this state, I will push A's. So initially, you know that initially in the stack, what we have the Z. This Z we have. This is the bottom of the stack symbol. Initially, this is in the stack. What I will do, without looking at the stack, don't pop the stack. What I will do, when this A comes in the input string, then without reading the stack, without looking at the stack, without popping anything from the stack, I will push it. Okay. For every A, I will push 1A. Okay. So remember, this A simply means that I'm pushing it. And this epsilon, this simply means that there is no pop. I'm not popping anything. I'm not looking at the stack. Okay. Now, after that, you can see m comma n, they are greater than equal to 1. So remember, there should be at least 1A. Do you agree? Because m comma n are greater than equal to 1. So there should be at least 1A. There should be at least 1B. So when the B comes, okay, here remember, for every A, I will push 1x. For every A, I will push 1x. Okay, so for every a I am pushing x. This is what I am doing. For every a I am pushing x. Then you can see when the b comes, then there should be at least one x in the top of the stack, because you can see m comma n are greater than equal to 1. So there should be at least one a, there should be at least one b. So when the b comes on top of the stack, there should be x. There should be x. Then what I will do? Then I will keep it as it is. Yes or no? I will not disturb it. I will actually push one more x, because for every a I will push one x, for every b I will push one x. You can see for every a push one x, for every b push one x. So you can see, okay, for every b what I will do? This x should be there on the top of the stack. Then I will not disturb it. I will push one more x. Okay, you can see, because remember here this will pop, this will pop, and this I will push. So finally here what I will do, for every b without reading the stack, don't look at the stack, just push one more x. Yes or no? So here this epsilon means what? This epsilon means there is no pop. And finally you can see when the c comes, then your top of the stack must have x. Yes or no? Then top of the stack must have x. Then in this situation I will pop it. Okay, for every c what I will do, I will pop one x. And then remember when the and marker comes, this string and marker, when this comes, then what I will do, then your top of the stack must have z. Okay, then I will go to final state. Okay, so this is your dpda, you can easily see. So that is the reason I can say this language is DCFL, because I can create DPDA. So that is the reason. That is the reason this language is a DCFL. Okay. Remember in the question they are asking, is this CFL or not? So you can create the context-free grammar also. For this language, I can create context-free grammar. If I can create context-free grammar, then this language will be context-free language. Yes or no? So very easily, actually, you can create the context-free grammar. Okay. So let me do this just for practice sake. You can see your language is actually like this: a power m, b power n. I am rewriting this language. I can rewrite, I can write like this: a power m, b power n, then c power n, c power m. Like this I can rewrite. Do you agree? Okay, so this language I can rewrite like this. Now here you can notice what I will do to write the context free grammar. What I will do, very simple: this b power n, c power n, this I can generate using variable a. This I can generate using variable a. And remember this a power m, c power m, this I can generate using variable s. You are using the variable start variable. Okay, so very simple. From the start variable, what I will do, I will generate a power m, c power m. Okay, so you can see for every a there should be c. So for every a there should be c using the start variable. Okay, now this start variable, in between it can go to s. This s can go to a. Yes or no? This middle s can go to a. This middle s will go to a. And using this a variable, I will generate b power n, c power n. Means for every b there should be one c. Okay, for every b there should be one c. And remember here one thing you can notice, that m comma n are greater than equal to 1. Okay, both are greater than equal to 1. So remember, okay, this will go to bc. Okay, you cannot put epsilon here, because m comma n are greater than equal to 1. So it will minimum, it will go to bc. Okay, and remember here also instead of writing a, what I can, because here m comma n are greater than equal to 1. Okay, so instead of writing a, I can write like this: AAC. Okay, is this clear? So this will be the context free grammar for this language. And because for this language I have context free grammar, so that is the reason I can say this language is CFL. Okay, very simple. Now let's move on now. So for this question, answer will be option B. This language is context free but not regular. And also this language is DCFL, because you can create DPDA. Let's solve this GATE 2007 question. The language L equal to 0 power I to 1 power I is greater than equal to 0. So tell me what about this language? 0 power I, 0 power I, then there is 2, then there is 1 power I. Okay, here the question is saying that I is greater than equal to 0. What do you think? What is this language? And the alphabet is 0, 1, 2. This is the alphabet, because we are using these symbols in the language 0, 1, 2. So this is the alphabet. Now you tell me, what about this language? 0 power I to 1 power I. This is not regular. Yes or no? Definitely this language is non-regular. Okay, why this language is non-regular? Because here you can notice what we need to do. We need to compare the number of 0 with number of 1. Yes or no? How many 0 are there? We need to compare with how many 1 are there. For example, if you have 100 0, then there should be 100 1. If you have 1000 0, then there should be 1001. So this type of comparison our finite automata cannot do. Okay, so that is the reason this language is non-regular, and this language is actually DCFL. Yes or no? This is a standard example of DCFL language. This type of languages are DCFL. You can easily create the DPDA. What you will do? What your DPDA will do? Tell me. For this language, what your DPDA will do? Your DPDA will basically do like this: that when zeros are coming, we will push. Okay, when this two will come, then we will skip it, and after that when the ones are coming, then we will pop. And remember, in the DPDA there is a end marker symbol. This symbol will tell you that string has ended. Okay, so you can see what your DPDA will do. When the zeros are coming, we will push. Okay, we will push all the zeros. For every zero we will push one zero. When the 2 is coming, then this we will skip. Okay, yes or no? Basically this 2 we will skip, and after that what we will do? We will start popping. We will start popping, and what we will do? For every one we will pop zeros. Okay, is this clear? So this is the idea. And remember, when the this end marker symbol comes, then your top of the stack must have Z. This must be your top of the stack. Okay, in this situation this string will be accepted, otherwise this string will be rejected. Okay, so this is the idea for DPDA. You can see push comma pop are clear. When to push, when to pop, when to start popping, how much to push, how much to pop, basically everything is clear. Okay, you can see. So that is the reason I can say this language is a DCFL. Every DCFL language is a CFL, so this language is CFL also. Every CFL language is CSL. Every CSL language is recursive. Okay, every recursive language is RE. Every recursive language is recursive enumerable language. So the question is asking which type of language is this? So you can easily see this language. The best answer will be that this language is non-regular but DCFL. This is non-regular but this is a DCFL. Okay. Now let's see the options. This is saying not recursive. This is wrong because every DCFL is CFL. Every CFL is recursive. Okay, every CFL is recursive. So this language is actually recursive. Okay. Now the question is saying this is recursive and this is DCFL. Yes, that is correct. Option B is correct. What about option C? It is regular. That is wrong. Option D is saying it is not DCFL. That is wrong because actually it is DCFL. Okay, yes or no? So very simple. So this is the idea. Very simple. If you want to create the DPDA, that also you can do. Okay. For this language, let me quickly create the DPDA. The DPDA will be like this, that for every zero I will push one zero. Okay, when the zeros are coming, then without reading the stack, without looking at the stack, without popping the stack, basically this epsilon means that there is no pop. What I will do? I will push one zero. Okay, this zero simply means I am pushing it. Now after that you can see when the 2 comes, when this symbol 2 comes, then what I will do? I will skip it. Yes or no? This symbol I will skip. Basically I will not do anything. I will not, no pop. I will not pop anything from the stack. I will not push anything from the stack. So you can see no pop from the stack, no push on the stack. Okay, basically this symbol 2 I am skipping. Basically this is the simple idea. When I write like this, then this simply means that this symbol 2 I am skipping. This means I am skipping this symbol 2. Okay, then what we are doing? Then what we will do? For every one we will pop 1 0. Okay, yes or no? For every 0 we are pushing 1 0, and for every one we will pop 1 0. You can see. And then you can see when the end marker comes, when this string end marker comes, then your top of the stack must have Z. Then I will go to the final state. Okay, is this clear? So this will be your DPDA. But here one more thing, that is, see, I is greater than equal to 0. So remember, this string also should be accepted. This string 2. Okay, if I take I equal to 0, then this string 2 also should be accepted because this also belongs to L. So remember, for this string what we will do? For this string W equal to 2. For this string, because remember this will be like this, W equal to 2, and there is end marker symbol. In the DPDA we have end marker symbol. So you can easily see. Okay, so this is what I'm going to do, that from the initial state, what I can do from in the initial state, if the first symbol is 2, okay, this is what I can do. Notice, in the initial state, if the first symbol is 2, if the first symbol is 2, okay, then I can go to a state. For example, if the first symbol itself is 2, if the first symbol is 2 and on top of the stack there is Z, then I can go to some state. Okay, I can go to a state. For example, I can go to this state, and in this state, this end marker symbol comes, then I will go to final state. Okay, is this clear? So you can see this string is also accepted. Now this is the perfect DPDA for this language. Okay, you can see now this DPDA is accepting this language. All the strings of this language are accepted by this DPDA, and you can see this is the DPDA for this language. So this language is DCFL. Okay, I hope you understood. One more thing I want to tell you, this is not the only DPDA that you can create. Maybe you can create some other DPDA, but the point is there exists a DPDA. So this language is DCFL. Okay, one more thing, whenever you are creating DPDA or PDA, then you don't have to worry about the which type of PDA or which type of DPDA you are creating. Okay, it does not matter. Are you creating the DPDA with more number of states or are you creating DPDA with less number of states? It does not matter. What matters? It matters that for any language, if you can create some DPDA, okay, any DPDA, if you can create, then that language will be DCFL. And for any language, if you can create some PDA, some push down automata, then that language will be CFL. Okay. Now, one thing again, I'm telling you, it does not matter which DPDA you are creating, which PDA you are creating. Are you using less number of states? Are you using more number of states? These things do not matter. Okay. So you can see for this language, we have created some DPDA. So this language is DCFL. Very simple. Okay. Let's move on now. Let's solve this GATE 2010 question. Here L1, L2, L3, L4, these are given to you, and the question is asking which of them is context free and which of them is not context free. Okay, so let's solve this question. You can see 0 power I, 1 power j, where I is not equal to j, I is equal to j, I is equal to 2j plus 1, I is not equal to 2j. Actually, all these languages are DCFL, yes or no? In our DCFL identification lecture, we have already seen that all these languages are DCFL. Every DCFL is CFL, yes or no? Okay, so you can see this 0 power I, 1 power j, where I is not equal to j, here I is equal to j, here I is equal to 2j plus 1, here I is not equal to 2j. All these languages in our DCFL identification lecture, identification of DCFL lecture, we have already seen all these languages are DCFL. Every DCFL is CFL. So all these are actually CFL. So the answer will be what? For this question, answer will be option D. Yes or no? But for practice, what we can do, for these languages, either you can create DPDA or you can create context-free grammar. If you can create context-free grammar, then language will be CFL. If you can create DPDA, then language will be DCFL. If you can create PDA, then language will be CFL. Yes or no? So just for practice sake, you can do that. Okay, so let me do this. For example, let's look at L1. The L1 is basically saying that there is 0 power I, 1 power j, and this is saying that I is not equal to j. I is not equal to j. Yes or no? This language is actually DCFL. I can create DPDA for this. Okay, I can create DPDA for this. Okay, so how to create the DPDA for this language? That is actually very simple. Remember, I is not equal to j, means either number of 0 is more than number of 1 or number of 1 is more than number of 0. Yes or no? So basically two type of strings are possible. Either number of 0 is more than number of ones, or or number of ones are more than number of zeros. Yes or no? So two type of strings are possible. But remember, number of 0 cannot be equal to number of 1, because you can see number of 0 is different from number of 1. Okay, so very easily you can create the DPDA. In the DPDA, what I told you there is an and marker symbol. Yes or no? Every string has a and marker symbol. This symbol will tell you that, okay, string has ended. So this is a special symbol to tell you that string has ended. In the DPDA, this facility we have and marker symbol. Okay, so let's create the DPDA. Very simple. In this initial state, what we will do, for every 0 we will push 1 0. Okay, for every 0, without looking at the stack, we will push 1 0. Okay, so you can see basically this means there is no pop. Okay, we are not popping anything from the stack. Without looking at the stack, without reading the stack, we are just pushing 1 0 on the stack. Okay, so on the stack you can see that initially what you have, on the stack there is z. Okay, then for every 0 we are pushing 1 0. Then what we will do, then remember, when 1 comes, okay, when this symbol 1 comes, then what we are going to do, we will pop 0. Yes or no? For every 1 we will pop 0. Okay, for every 1 0 we will pop. Okay, you can see. Now after that, you can notice that there are two possibilities. Either you have more 0, less number of 1, or you have less number of 0, more number of 1. So tell me, in this type of situation, what will happen? In this type of situation means what will happen here? If your string has this type of situation, okay, means you have more 0 and less number of ones, then what will happen? Then this end marker will come. Then this end marker will come. Okay, I hope you are getting the point basically, because remember, for every zero you are pushing one zero. For every zero you are pushing one zero. Okay, then what you are doing? For every one you are popping one zero. Then you can see when this end marker comes, then what will happen? Then your top of the stack will have zero. Then your top of the stack will have zero. Now you can just go to final state. Okay, that's it. Or what can happen? Or your string can have this format. Or your string can have this format, means your string can have less number of zero, more number of ones. Okay, so what will happen? For every zero we will push one zero. Okay, so you can see there are three zeros, so we will push three zero. Then for every one we will pop one zero. For every one we are popping one zero. Now you can notice when we come to this, when we come to this string, okay, you can see what will happen. Basically, when we come to this string, then what will happen? On top of the stack there will be z. Yes or no? On top of the stack there will be z. So you can see when we come to this one, this symbol one, then on top of the stack there is z. Now we know that, okay, we have more number of ones. Okay, we have more number of ones. Then what we will do? We will just go to final state, and in the final state, these remaining ones I will read. In the final state, the remaining ones I can read. Okay, and when this end marker comes, this also I can read. When this end marker comes, I will read this. So that's it. This is your DPDA for this language. Is this clear? Please tell me. Okay. So very easily you can create the DPDA. Okay. I hope you understood. So for this language, we can create DPDA. That is the reason I can say that this language is DCFL. Okay. Is this clear? Let me know. Now, let me tell you, there are some corner cases. For example, the string 0 should be accepted and the string 1 also should be accepted. Yes or no? Okay, so there are some corner cases. Can you handle those corner cases? For example, the string 0 should be accepted and the string 1 also should be accepted. This type of string should be accepted. For example, if you have zeros, then this should be accepted. And if you have ones, then this also should be accepted. Okay, so for these, what I can do? Remember, very simple, I can do that after zeros, after pushing all the zeros, if the end marker comes, means in this state, if end marker comes, then just go to final state. See, after pushing all the zeros, okay, all the zeros you are pushing, after pushing all the zeros, if end marker comes, okay, in this initial state, in this state q0, if end marker comes, if this end marker comes, then what we will do? Okay, on the stack, what is there? On the stack there is 0. Then we will just go to final state. Okay, is this clear? So you can see this type of strings should be accepted. Very simple point. I hope you understood. So you can see after pushing all the zeros, okay, there are 3 0, we will push them. Then when the end marker comes in this initial state, then we will just go to the final state. Similarly, this string should be accepted, double one should be accepted. So what we will do? Remember, okay, this double one should be accepted. So you can see if the first symbol itself is 1 in the initial state, if the first symbol itself is 1, then what we can do? If the first symbol is 1 in this initial state, if the first symbol itself is 1, on top of the stack there will be z. Yes or no? On top of the stack initially there will be z. Then I will just go to this final state and I will read the remaining ones. Okay, so on this first 0 I will go to this, sorry, on this first one, if the first symbol itself is 1 in the initial state, if the first symbol itself is 1, then I will go to this final state and the remaining ones I can read in this state. So now this is the perfect DPDA for this language. Okay, is this clear? Now this DPDA is covering everything. This DPDA is covering all the strings which belong to L1, all the corner strings. Okay, so this is the perfect DPDA for this language L1. This DPDA is accepting all the strings which belong to L1, and this is not accepting any string which does not belong to L1. So this is the DPDA for L1. That is the reason L1 is DCFL. Okay, is this clear? So very simple, L1 is DCFL, and L2 is very simple. That is 0 power n, 1 power n. Okay, that is your standard language, 0 power n, 1 power n. For this language, what you can do? You can easily create the context free grammar. Okay, so let me create the context free grammar. That will be like this. For every 0 there should be 1. Yes or no? So remember, for every 0 there should be 1. That's it. So this is the context free grammar I can create. Because context free grammar exists, that is the reason I can say this language is what? This language is CFL. Yes or no? So I can say that L2 is a CFL. The question is asking which is CFL. So L2 is CFL. What about L3? L3 is also CFL. Okay, for L3, what I can do, I can create the, this is the language L3, this is 0 power I 1 power j, where I is equal to 2j plus 1. Okay, this is the language. Now for this language, what I can do, I can create the context free grammar. So this language will be context free language. Of course, this language, if you notice, this is DCFL also. Remember, all these languages are actually DCFL. Okay, but the question is not asking for DCFL, the question is asking for CFL. Okay, so what we need to do, for CFL, what I can do, I can create the context free grammar. If I can create the context free grammar, then that language will be CFL. Yes or no? So for this language, remember, I can rewrite this language. I can say that I is equal to 2j plus 1. So it's like this, 2j plus 1 and 1 power j. I can rewrite this. I can say that it is like 0, 0 power 1, then 0 power 2j, then 1 power 2j. Okay, this is how I can rewrite. Now what I can do, this I can generate using variable a. Okay, this I can generate using variable a. Then this is the context free grammar I will get for this language. The context free grammar will be s going to 0a. Okay, 0a. There is 0, then there is a. Now this a will generate 0 power 2j, 1 power j. Okay, so you can see this a will generate what? It will generate for every 2 0 1. Okay, for every 2 0 there is 1 1. So this is what we are going to generate. So this is the context free grammar for L3. Because L3 has a context free grammar, so that is the reason I can say that this language will be what? This language will be CFL. Okay. For any language, if there is context free grammar, then that language will be CFL. So you can see L3 is a CFL. Okay. Let me tell you about L4 also. Okay. Look at this L4. If you create the DPDA, yes, DPDA is possible, but it will be complicated. Let me tell you. Okay. All these languages are DCFL, means DPDA exists. For all these languages, you can create DPDA. Okay, very easily you can create DPDA for these languages. For this L4 also you can create the DPDA, but the DPDA will be little bit complicated. Okay, you will have to check all the situations. You will have to check that I is not equal to 2j. So either I is less than 2j or I is more than 2j. Okay, so basically you have to check all the possibility and then you can create the DPDA. Okay, that I leave up to you. You don't have to create, don't worry. Okay, you do not have to create the DPDA. The question is not asking for DCFL. You already know that this is DCFL because this type of languages are actually DCFL. Okay, now let me tell you that another proof that this is DCFL, another way. Okay, let me tell you another way that this is DCFL, because you already know, if you remember, if I have I equal to 2j, then that is DCFL. Yes or no? See, if I give you like this 0 power m, 1 power n, and if I say that m is equal to 2n, if I say m is equal to 2n, then this is very easy. This is actually very easy. You can easily create the DPDA. Very easily you can create the DPDA. What you will do? M is equal to 2n. So what you will do? For every 2 0, you will push 1 0. And for every 1, you will pop 1 0. Yes or no? This is the idea. That basically here what you will do, remember, because m is equal to 2n. So it's like if you have 6 0, then there are 3 ones. So what you will do? For every 2 0, you will push 1 0. For every 2 0, you will push 1 0. For every 2 0, you will push 1 0. So finally, you are pushing 3 0. Then for every 1, you will pop 1 0. Then when the end marker comes, I am creating the DPDA. In the DPDA, there is a string end marker symbol. When this string end marker symbol comes, then your top of the stack must have Z. Okay. Then you will accept the string. Otherwise, you will reject the string. So you can see for this language, when your m is equal to 2n, then very easily you can create the DPDA. It is very easy. Now I told you that DCFL complement is DCFL. Yes or no? I told you that the complement of DCFL language is DCFL. Okay. So this language L is DCFL. So that is the reason its complement also will be DCFL. Okay. Now let me tell you that consider this language L4. What is this language L4? That is 0 power m, 1 power n, where m is not equal to 2n. This is your language L4. I am taking this language L4. Here you can see 0 power m, 1 power n, where m is not equal to 2n. Okay, so you can see this is the language L4. Now you find what is the complement. Can you find? See, this L4 complement, can you find? I am asking L4 complement. So tell me, what is L4 complement? This is the language, remember. Your language is this. This is your L4. So can anyone tell me what is L4 complement? A student is saying that L4 complement will be this 0 power m 1 power n, where m is equal to 2n. Can I say this is the L4 complement? Is this the correct answer? Tell me. Is this answer correct? Simple question I'm asking. You know this is your L4. This is L4. Then what is L4 complement? Can I say this will be L4 complement? In L4 we have m not equal to 2n. So in L4 complement we will have m equal to 2n. So can I say this answer is correct? This answer is wrong. This answer is wrong. Is this clear? This L4 complement is actually wrong. Okay, can anyone tell me why this is wrong? Why this L4 complement is wrong? Because the reason is very simple. What the definition of complement? The reason is actually very simple. Tell me what the definition of complement. Whenever you have L complement, that means those strings which do not belong to L. Yes or no? Set of those strings which do not belong to L. So you can easily see in this L4 which strings do not belong. In this L4, actually, yes, these strings do not belong to L4. So yes, these strings will be in the L4 complement, but focus on these strings which contain 1 0. W contains 1 0 means after 1 0 comes. Tell me one thing. After 1 if 0 comes, then that string will be in the L4 or not? Or not? Tell me. See, very simple point. What is L4? L4 is 0 power m 1 power n, where m is not equal to 2n. Okay, you can easily see in L4 we don't have this type of string. Okay, in L4, like after 1 if 0 is coming, then these strings, for example, after 1 if 0 is coming, then this type of strings, they do not belong to L. Yes or no? This does not belong to L, this does not belong to L4. Okay, they do not belong to L4. So they must belong to L4 complement. Do you agree? In the L4 complement, this string should be there. This string should be there. This string should be there. After 1 if 0 is coming, that string should be there. This string should be there. Okay, this string should be there. So basically after 1 if 0 is coming, then that string should be there in the L4 complement. I hope you are understanding the point. Okay, so remember this is your L4 language. So what will be L4 complement? That will be all those strings which are not in L4. Okay, remember L complement means all those strings which are not in L. So you can see these strings are not in L4. Okay, you can see. Okay, when you have 0 power m 1 power n, where m is equal to 2n, these strings are also not in L4. These strings are not present in L4. Also, these strings are not present in L4, where w contains 1 0. Okay, is this clear? So now you focus on one thing. Now you focus on one thing, that this is your DCFL. Yes or no? This part is DCFL. Okay, m is equal to 2n. You can see this is DPDA. You can create the DPDA easily. And this language is regular. Yes or no? W contains 1 0. This is regular. This is regular. So what I can say about L4 complement, that is DCFL union regular. Can I say L4 complement is DCFL union regular? And DCFL union regular is a DCFL, that you already know, that DCFL union regular. If you have a DCFL language union with regular language, the result always will be DCFL. Okay, so you can easily see that this L4 complement is actually DCFL. Yes or no? Do you agree? L4 complement is DCFL. If L4 complement is DCFL, then what will be L4? If L4 complement is DCFL, then tell me. Okay, for a moment, this L4 complement, let me call it some other language. For example, let me call it Y. Okay, so you can see what is Y. Y is basically L4 complement. Okay, is this clear? I am saying that L4 complement is Y. I am writing L4 complement equal to Y. So you tell me, if Y is DCFL, then what will be Y complement? DCFL complement is DCFL, that you already know. Okay, so let me write it here. DCFL complement is equal to DCFL. Okay, agree? So you can see if Y is DCFL, then what will be Y complement? That also will be DCFL. Tell me what is Y complement? If Y is L4 complement, then what will be Y complement? That will be L4. If Y is L4 complement, then Y complement will be L4. Yes or no? Okay, so remember Y complement will be DCFL. That simply means L4 is DCFL, because Y complement is DCFL. Y complement means L4. Okay, so you can see L4 will be DCFL. So this is how you can easily see that L4 is DCFL. Please tell me, did you understand? So we have seen that this L4, we have seen that this is a DCFL. Every DCFL is CFL. So that is the reason I can say. Anyway, answer will be option D. Actually, this question was very simple. Let me tell you. For this question, actually, you don't have to do anything because all these are standard languages which are DCFL. Do you agree? Yes or no? In the GATE 2010, these four languages came. You can see this was a definitely this was a 2 mark question. Now you can see all these are standard languages which are DCFL. In our DCFL identification lecture, how to identify whether a given language is DCFL or not, in that lecture we have already seen all these languages. Okay, all these type of languages are actually DCFL. Okay, so that is the reason easily you can say that answer will be option D. But anyway, we have done the complete analysis of each option. Okay, for option A we have created DPDA. Option B also you can easily see. Option B we have created context free grammar, so it is CFL. Option C we have created context free grammar, so it is also CFL. And for option L4, for L4 we have seen that this is DCFL. Okay, by a different way. Okay, for L4 we have seen that DCFL complement is DCFL. So these properties we have used. Okay, using the properties DCFL union regular is DCFL. So using these properties, we have seen that L4 is also DCFL. Okay, I hope you understood the complete analysis of this question. Let's solve GATE 2011 question. So language L1, L2, L3, these are given to you. The question is asking, push down automata can recognize L1, L2. L1 is regular. All three are context free. Turing machine can be used to recognize all these languages. So let's see which statement is not true. The question is asking which statement is false. Okay, so let's see one by one. Let's see the statement. The language L1. What that? That is 0 power p, 1 power q, where pq are natural numbers. Look at L1. L1 is 0 power p, 1 power q, where pq both are set of natural numbers. Okay, so tell me, is there any relationship between p comma q? Tell me, is there any relationship, is there any comparison between p comma q? No, there is no comparison. So actually this I can write. Remember the set of natural numbers. If you take for example, see this set of natural number, you can start from 1 or you can start from 0. That is your choice. Okay, because let me tell you, this is set of natural number. Some people they start from 0. Okay, some people they start from 0 and some people they start from 1. Which do you prefer? Let me know. Let me tell you, the computer science people they start from 0. Okay, sometimes you will see that computer science people they start from 0, the set of natural number, and the mathematics people they start from 1. What do you prefer? Mathematics people. Okay, anyway you can take any of them, does not matter. In this question it does not matter. Okay, you can see in our childhood, in our school life, we have seen that natural numbers are these, they start from 1. But let me tell you, in the computer science books, in some computer science books, or I can say in many computer science books, the natural numbers they start from 0. But anyway, you don't have to worry. Okay, in this question, whatever you take, for example, if you take n is starting from 0, then what answer will be? And if you take n is starting from 1, then what answer will be? Okay, let's see. The answer will not change. Okay, this language will basically will be regular. Yes or no? This language will be regular. Here you can see there is no comparison between p comma q. Yes or no? P comma q, they are completely independent. Okay, so here you can easily see, if I assume that set of natural numbers are starting from 0, then this language will be what? Then this L1 I can write using a regular expression, that will be 0 star 1 star. Any number of 0 followed by any number of ones. Yes or no? Is this clear? Because 0 power p, 1 power q, p comma q have no relation. There is no comparison between p comma q. So any number of 0 followed by any number of 1. And remember, if you start natural numbers from 1, then also no problem. Then the language will be what? That the language will be 0 plus 1 plus. Okay, anyway, in both the situations you can easily see that language L1 is basically regular. L1 is regular. Okay, is this clear? Every regular language is a CFL. Every CFL language is recursive enumerable. Recursive enumerable are those languages which are Turing machine recognizable. Recognizable. Okay, so remember, every regular language is Turing machine recognizable. Yes or no? Every regular language that is Turing machine recognizable. Okay, so here you can easily see that this language L1, I can say this is a regular. Okay, what about the next language? That is 0 power p, 1 power q, where p is equal to q. Okay, so what about this language? Tell me. What about this language? L2. L2 is saying that you have 0 power p, 1 power q, and the question is saying p is equal to q. So here you can easily see, basically this L2 I can write like this, 0 power n, 1 power n. Yes or no? Like this I can write, because anyway p is equal to q. And this is a standard language where n belongs to set of natural numbers. Okay, this language is not regular. Okay, this language is a standard language which is non-regular. Here you have to compare how many 0 with how many 1. Yes or no? Because remember, number of 0 should be equal to number of 1. So you have to remember how many 0 are there so that you can compare with number of 1. Okay, this type of unlimited memory is not there in the finite automata. Because if you have 1000 0, then there should be 1000 ones. If you have 10,000 0, then there should be 10,000 ones. Okay, if you have 1 crore 0, then there should be 1 crore ones. So like that. Okay, so you can easily see this language is non-regular, and this is a standard language which is DCFL, because you can easily create the DPDA. What you will do, for every 0 you will push 1 0 in the stack, and for every 1 you will pop 0 in the from the stack. Yes or no? For every 0 you will push 0 in the stack, and for every 1 you will pop 0 from the stack. So this is a DCFL. Every DCFL language is CFL. Every CFL language is recursive enumerable, and recursive enumerable languages are basically Turing machine recognizable. Turing machine recognizable. So I can say that every DCFL language is Turing machine recognizable. Okay, I can say every DCFL language is Turing machine recognizable. Is this clear? So very simple point here, I can say that this L2 is a DCFL but not regular. Okay, non-regular. What about L3? L3 is saying that 0 power p, 1 power q, 0 power r, where p, q, r are same. This is a standard example of non-CFL. Yes or no? But this is CSL. Okay, but this language is CSL. This language is CSL. And remember, every CSL is recursive enumerable. Recursive enumerable means Turing machine recognizable. Turing machine recognizable. So very easily you can see that all the languages are actually Turing machine recognizable. Yes or no? You can see Turing machine can recognize all these languages. This statement is actually true. The question is asking which statement is not true. Okay, see, look at this language L3. This language L3 is basically 0 power p, 1 power q, 0 power r. Okay, 0 power r. And the question is saying that p, q, r, they are natural number, and p is equal to q, p equal to q is equal to r. Okay, so this L3 I can write like this: 0 power n, 1 power n, 0 power n, and this is a standard language which is not CFL. Yes or no? This language is not CFL. In the lecture also we have seen that this language is non-CFL. Also in our context-free language detection lecture, identification of context-free languages, in that lecture also we have seen that this language is not CFL. Because here what your PDA will do, if you assume for a moment, if you assume this is CFL, then there is a PDA. If you assume there is a PDA, then what your PDA will do? Your PDA will basically do like this. See, when the zeros are coming, your PDA will remember zeros by pushing them in the stack. Okay, because we have to compare number of 0 with number of ones, and we have to compare number of ones with number of zeros. Okay, so remember, our PDA, what our PDA will do? Our PDA will push these zeros in the stack. Okay, because we need to compare number of 0 with number of ones. So we need to remember how many 0 are there. So we will push them in the stack, these zeros. And then what we will do? We need to compare this number of 0 with number of 1. So what we will do? We will pop zeros. Yes or no? For every 1, I will pop 1 0, so that I can compare that how many 0 are there, how many 1 are there. But now you notice, after this is over, and when you are standing here, when your push down automata is standing here, now all the zeros are gone, all the ones are gone. Okay, when your PDA is standing here, then you can notice that your stack has Z. Yes or no? This is what is there in the stack memory, because with all the zeros we have compared all the ones. Now you can see, initially we are pushing all the zeros in the stack, but for every one we are popping 0. Okay, so you can see when you are standing here at this moment, when you are standing here, then your stack does not contain any information about how many 0 are there, how many 1 are there, yes or no? So remember this information, how many 0 are there, how many 1 are there, this information is gone. Now we cannot compare this number of ones with number of zeros, yes or no? So this is the idea, that here there is nothing to compare with this 0 power n. Okay, I hope you understood. So remember here I can say nothing, there is nothing remaining, there is nothing remains to compare with 0 power n, to compare with these 0 power n. Okay, these 0 power n. So that is the reason I can say PDA cannot do this. So this language is non-CFL. But remember, this language is CSL. Okay, yes or no? This language is CSL. I told you one rule of thumb. If you remember in the CSL lecture, I told you that for any language, see, look at this language. Why this language is CSL? This L3 is 0 power n, 1 power n, 0 power n, where n belongs to set of natural number. Okay, let me tell you why this language is CSL. I told you one rule of thumb, that was that for any language, if you can find the strings which belong to this language without depending on any encoding, then that language will be CSL. Yes or no? Is this clear? If you remember, I told you that for any language, if you can find exactly which strings belong to the language, for this language, I can find which strings belong to the language without depending on any encoding. Yes or no? Okay, so that is the reason this language is CSL. I told you that any language for which you can find exactly which strings belong to the language without depending on any encoding, that language will be CSL. Here you can notice I can easily find the strings in the language without depending on any encoding. Here, if you take n equal to 1, then if you take n equal to 1, this string will belong to the language. If you take n equal to 2, this string will belong to the language. If you take n equal to 3, this string will belong to the language, and so on. So you can see I can easily find the exact strings which belong to the language without depending on any encoding. Okay, the exact strings in the language I can find. So that is the reason this language is CSL. Okay, very easy. So finally I can say that L3 is CSL. And which option will be correct? Now you tell me. The question is asking which statement is not true. Look at option A. Option A is saying that PDA can recognize L1, L2. Yes, that is correct, because L1, L2. So option A is actually true. The question is asking which is not true. Option A is true. Option D is also true. Okay, what about option B? Option B is saying that L1 is regular. Yes, that is also true. Okay, what about option C? Option C is saying that all are context free. No, L3 is not context free. Yes or no? L3 is not CFL. Okay, so your answer will be option C. Okay, very simple. I hope you understood. So remember, for this question, answer will be option C. Let's solve this GATE 2013 question. Two languages are given to you, L1, L2. L1 is 0 power P, 1 power Q, 0 power R, where P, Q, R, they are greater than equal to 0. Is there any comparison between P, Q, R? Tell me. Is there any comparison between P, Q, R? Here you can easily see the language L1 is 0 power P, 1 power Q, 0 power R. Okay. And the question is simply saying that P, Q, R, they are greater than equal to 0. Okay. Just tell me a simple point. Is there any relationship? Is there any comparison between P, Q, R? There is no comparison. Yes or no? So in this situation, what I can say? This language is actually regular. Okay, this language is actually regular, because here number of P, number of Q, number of R, they can be anything. P can be any value greater than equal to 0. Q can be any value greater than equal to 0. R can be any value greater than equal to 0. So for this language, I can write the regular expression, that will be any number of 0 followed by any number of 1 followed by any number of 0. Yes or no? So this regular expression, this is the regular expression. So that is the reason I can say this language will be also regular. So L1 is a regular language. Okay. Remember, the question is asking which is CFL. Okay, so you can see every regular language is CFL. So L1 is a CFL also. So I can say L1 is CFL also. Okay, so I can say L1 is recursive also, because every CFL is CSL, every CSL is recursive. So I can say L1 is recursive also. Yes or no? All these things are correct. Okay, so here I can say that this is actually regular. What about option L2? What about the language L2, that is 0 power P, 1 power Q, 0 power R, where P is not equal to R? Okay, so let's see what is the language L2. The language L2 is like this, that is 0 power P, 1 power Q, 0 power R, where PQR, they are greater than equal to 0. Okay, all of them, they are greater than equal to 0. And the question is saying that P is not equal to R. Okay, P and R, they are different. But here you can notice there is no relationship between Q comma P. There is no relationship between Q comma R. Yes or no? So remember Q, if you look at Q, this is just any value greater than equal to 0. Okay, so this same language I can write like this, that you have 0 power P. Okay, remember Q has no relationship between this Q has no relationship with P comma R. Yes or no? So I can say it is like 1 star and then 0 power R. Okay, is this clear? Where where P should not be equal to R. Very simple. So this is what I can write. This language I can write like this. Now you can easily see this is a DCFL language. Yes or no? This type of languages are DCFL. We have already seen in our DCFL identification lecture. So this language is actually DCFL. Okay, is this clear? Because here what you can do, you can create the DPDA. Okay, so remember every DCFL language is CFL. So this language is CFL also. So this language is recursive also. Okay, you can create the DPDA. Let me create if you want. Okay, let me create the DPDA so that I can prove that yes, this is a DCFL. Okay, so what is the idea? If I want to create a DPDA, then what the idea? The idea is very simple. What I will do, when zeros are coming, I will push them. Okay, when ones are coming, I will ignore them. And when zeros are coming, I will pop. So you can easily see what I will do. Here I will push. Here I will push zeros. Okay, for every zero I will push 1 0. Then remember these ones I will skip. Okay, I will ignore these, I will skip. And then what I will do, then I will start popping. Okay, then I will pop zeros. In the DPDA there is end of string symbol. So this end of string symbol is there. This symbol will tell you that string has ended. In the DPDA we have end of string marker. Okay, so you can see when this string marker comes, then your top of the stack must have Z0. Yes or no? Your top of the stack must have Z0. This should be there in the top of the stack. Then you will accept the string, otherwise you will reject the string. Yes or no? Okay, so here you can see we can easily create the DPDA. Sorry, at the end what should happen? P is not equal to R. Notice P is not equal to R. So either zeros are more, or either these zeros are more or these zeros are more. Yes or no? See, notice the question is saying P is not equal to R. So at the end what should happen? At the end there are two situations. At the end there are two situations. Okay, I will explain, don't worry. Let me create the DPDA. The DPDA I will create like this. See, the strings, two type of strings are possible because P is not equal to R. So there are two type of strings possible. Either these zeros are more or these zeros are more. Do you agree with me? Very simple point, that only two type of strings are possible. Either you have, like for example, these zeros are more, okay, and these zeros are less, and there is end marker, or or this type of string where the initial zeros are less, okay, and then you have more zeros here, and then there is end marker. Okay, so these two type of strings are there. Do you agree? So here what we are going to do, very simple point. Let's create the DPDA. It will be like this. In the initial state, what I will do, for every zero I will push. Okay, is this clear? For every zero I will push. So initially in the stack, what I have, initially in the stack there is Z. There is this symbol Z in the stack. Okay, so what I will do, initially remember these zeros that are coming, I will keep pushing them. Okay, all the zero, without looking at the stack I will push. Okay, what this means, this simply means I am pushing zero. And what this means there is no pop. Yes or no? I am not popping anything. Okay, basically without looking at the stack, without reading the stack, without popping anything from the stack, I am just pushing zero. Okay, so you can see first I am considering this type of strings. Okay, so you can see for every zero I will push 1 0. Then you can notice what I will do, when the ones are coming. Okay, when the ones are coming, I will ignore them. Now I will not disturb the stack, I will not pop anything, I will not push anything. Okay, yes or no? All these ones I will ignore. All ones are coming, I will ignore. I will not disturb the stack. Okay, yes or no? because you can see one star. So I will not disturb the stack, I will not push anything, I will not pop anything. Then you can see when the zeros are coming, then more zeros are coming, then I will pop zeros. For every zero I will pop zero. Okay, for every zero I will pop zero. Then let me tell you, in this state also what I will do, for every zero I will pop zero. Okay, so this is what I'm going to do. Now something interesting, what that, see there are two type of strings that are possible. If your string has this type of format where these zeros are more than these zero, means p is greater than r. Okay, then what will happen, first let me consider this type of strings. So in this type of strings what I will do, I will push all the zeros, I will push all the zeros. Okay, after pushing all the zeros, you can see after pushing all the zeros, these ones I will skip. Okay, these ones I will skip. Then for every zero I will pop 1 0. Okay, there are 2 0, so I will pop 1 0. Okay, is this clear? Now you can see when the end marker comes, then tell me what should happen. When the end marker comes, means I am considering p is more than r. So tell me, when end marker comes, then there should be 0 in the top of the stack, yes or no? When the end marker comes, then there is 0 on top of the stack, you can easily see. End marker is coming, then on top of the stack there is 0. Then I will go to, final state. Okay, very simple point. Now remember, if my string has this format, means r is more than p, then what I will do, if my string has this format, means remember what will happen for this type of string, means r is more than p, for every zero I will push zero, yes or no? Okay, remember, because for every zero I am pushing zero, so for 3 0 I will push 3 0. Then I am ignoring all the ones, these three ones I will ignore. Then what I will do, for every zero I will pop 1 0. You can see for every zero I am popping 1 0. So you can see for these three zeros will be gone. Okay, now you notice when this zero comes, focus on this zero, means in this state, when zero comes, then on top of the stack there is zero, there is z. Okay, then I will go to another final state. Now remember, in this final state I will read the remaining zeros. In this final state I will read the remaining zeros. Okay, I will also read the this end marker, this string end marker also I will read. Okay, in this state the string end marker also I will read. So this is the DPDA for this language. Did you understand? Please tell me. Very simple. This DPDA is not a complicated thing. Here you just have to consider two situations. Okay, what are those two situations? Either p is more than r or r is more than p. Yes or no? Okay, because here you have to consider two situations, that either p is more than r or p is less than r. Okay, so two situations you have to consider. Okay, when p is more than r, then this final state I've created, and when p is less than r, then this final state I've created. So this is the DPD that you will get. I hope you understood. Here this DPD we got for this language, but there are some corner cases which are remaining. What are the corner cases? For example, if q is 0, if p is 0, if r is 0, then what will happen? So these corner cases are remaining, yes or no? For example, if p is 0, okay, consider if q is 0, okay, means if number of ones, because remember pqr they are greater than equal to 0. Okay, tell me, if q is 0, then tell me this type of strings should be accepted or not. For example, if you have any number of zeros, okay, if you have q is 0, means there is no one, then in this situation tell me, should I accept every string? Let me know, should I accept every string? See, empty string should not be accepted because p is not equal to r. Yes or no? The question is saying p is not equal to r. So empty string does not belong to L2. You can easily see. Okay, remember empty string. I can say that empty string does not belong to L2 because p is not equal to r. Okay, so they must be different. P comma r, they must be different. So you cannot take both of them 0. Okay, for example, can you take p comma r both of them 0? Is it possible? P, R, can you take both of them 0? Like P is also 0, R is also 0. Can you take? No, you cannot take. That is the reason empty string does not belong to the language. Now you tell me, if Q is 0, means there is no 1. In this situation, can I say 0 plus? Can I say that will belong to the language? Can I say that should belong to the language? Okay, what about this string? Just tell me a simple point. What about this 0 power 2, 0 power 2? This string should belong to the language or not? Let me know. If q is 0, then tell me 0 power 2, 0 power 2, this string should belong to the language or not? Should it belong to the language? or should it not belong to the language? It must belong to the language. Why? What the reason? Because remember, here what I can do, here I can consider the entire string as, see, this 4 I can consider as p, and 0 power 0 and 0 power 0, basically this I can consider as r. I hope you are getting the point. What I'm saying, I'm saying that 0 plus will belong to the L2, because remember, if you have any number of zeros, okay, if you have, for example, 0 0, okay, any number of zeros you have, then what you can do, this entire you can consider as p. Okay, so you can take p equal to 2, and you can take q equal to 0, sorry, r equal to 0. Is this point clear? For any number of 0, basically this is the point. For example, if you have this string 0, then what you can do, you can take p equal to 1, you can take r equal to 0. Okay, so whatever string you take, for any string, what you can do, you can take p equal to, okay, for this string I can say that you can take p equal to 4. Okay, for this string you can take p equal to 4, you can take r equal to 0. Okay, I hope you are getting the point. Is this clear? So remember, these strings will belong to L2. Okay, so we should take care of these strings, that if you have any number of zeros, then they should be accepted. Okay, so in the dpda, in this dpda I will make some changes. Okay, initially I am pushing all the zeros. Do you agree? All the zeros I am pushing. So after pushing all the zeros, if this string means, if this type of string comes, for example 0 epsilon, if this type of string comes, or if this type of string comes, then what should I do? Tell me. Basically, if my strings are like this, then what should I do? I should accept them, yes or no? So remember, what I will do, I will make this transition, that in the initial state, from the initial state, okay, in the initial state I'm pushing all the zeros. Remember, in this initial state I'm pushing all the zeros. Now in this initial state, if this bottom symbol comes, if this end marker comes, then I will go to final state, yes or no? Okay, remember I'm pushing all the zeros. Then remember, if this end marker comes, on top of the stack there is 0, then I will go to final state. I hope you are getting the point. Very simple. Okay, what I'm saying that, okay, see, in the initial state I'm pushing all the zeros. Okay, so if your string is like this, for example, let's assume your string is like this, 40, your string is 40, and then there is string end marker, this is the string end marker. Then what I will do, in the initial state I will push all the zeros, these all 4 zeros I will push in the initial state, I will push them. Then when the end marker comes, in the initial state q0, if the end marker comes, then your top of the stack will have 0. Now I will go to this final state. Now you can see these strings 0 plus, these strings are accepted, all these strings 0 plus are accepted. Okay, so this is the corner cases that we have covered. What more corner cases are possible? What more corner cases are possible in this L2? This was 0 power p, then there is 1 star, and there is a 0 power r. Okay, where p comma r both are greater than equal to 0, where p is not equal to r, and where q is greater than equal to 0. Okay, so we have considered this q equal to r, this q equal to 0 possibility considered. Okay, this possibility, remember, this possibility we have covered. We have covered this possibility. Now you tell me, if you have p equal to 0, then tell me which type of string should be there. If I have p equal to 0, now remember, q equal to 0 I have covered. Okay, so now you can assume that q is not equal to 0. Okay, because q equal to 0 I have already covered, the possibility of q equal to 0 I have already covered. So here you can assume that q is not equal to 0, but p is equal to 0. Okay, you can consider this situation. Okay, so you can consider this situation, that q is not equal to 0, but p is equal to 0. In this situation, which type of strings will belong to the language? Here you can see that your language will have 1 plus followed by 0 plus. Yes or no? This type of strings will be there, 1 plus then 0 plus. Okay, similarly, you remember, if I consider these possibility like q is not 0, okay, and here q is not 0 and r is not 0, but r is 0. Okay, q is not 0, but r is 0. Okay, then in this situation I should have 0 plus 1 plus. So basically these also I have to cover. Okay, in the dpd I have to cover these possibility also. So what I will do, notice, let's see the first one. This means after once if zeros are coming, then that should be accepted. Okay, there is no 0 here, so this possibility I need to cover. So what I will do, notice, in the initial state the first symbol is 1. If the first symbol is 1, then what should happen? In the initial state, if the first symbol is 1 and on top of the stack there is a z, okay, then what should be done? So if the first symbol is 1, then I will go to this state. Okay, that is fine. If the first symbol is 1, then after that, what I will do? From this state, I can say that in this state I am ignoring all the ones, and then from this state, what I can do? In this state, so here I am ignoring all the ones. Then you can see in this state, if 0 comes and on top of the stack there is z. Okay, in this state, if 0 comes on top of the stack there is z. In this state, on the top of the stack there is z. Then what I will do? Then I will go to this final state. Very simple point. Remember, if 0 comes on top of the stack there is z, then I will keep it as it is and I will go to this final state. In this final state, the remaining zeros I will ignore. Okay, I hope you are getting the point. The remaining 0 I will ignore. So this is the point. So now you can see that this also I have covered. Remember, these also I have covered. These also I have covered. Okay, what about this next one? 0 plus 1 plus. What about these? 0 plus 1 plus. So let me check. So you can see all the zeros I will push here. Okay, then 1 plus, 0 plus, then there is 1 plus. Then here in this state, if directly and marker comes, okay, yes or no? In this state, if directly and marker comes, then what I will do? Then I will go to this state. Okay, so this one more transition I need to put. I need to put this transition that. So notice here, I need to put this transition that in this state. Okay, in this state, if direct and marker comes, then what I will do? On top of the stack there is 0. Okay, and marker is coming. On top of the stack there is 0. Then what I will do? I will just go to this final state. Okay, that's it. Now let me tell you, this is the perfect DPDA for this language. Okay, you can check it out. If you did not understand, then you do it yourself. Okay, I know that there are some students who did not understand this last part. Okay, because we have to cover the possibilities, the corner cases. When Q is 0, when R is 0, when P is 0, these corner cases we have to cover. I know there are some students who did not understand the last part. Basically, when we are covering these possibilities, some of you did not understand. But I suggest you one thing, that you do it yourself. You create this PDA on your copy pen, take a copy pen, do it yourself. Okay, check it. Check it. This is the perfect DPDA for this language L2. Okay, this DPDA is accepting all the strings of L2. All the corner cases are covered in this DPDA. Anyway, the point is very simple. In this question, if you notice in this GATE 2013 question, actually you don't have to create the DPDA. Okay, is this clear? You do not have to create the DPDA in this question, because remember, you already know that this L2, okay, this L2, that is basically, that is DCFL. Yes or no? This is a standard language, that is DCFL, that you already know. Okay, this type of languages we have already seen. These are DCFL. So actually you don't have to create the DPDA. Okay, but still, just for practice, I've created DPDA. I hope you understood. If you did not understand, don't worry about it. Okay, because you already know that this L2, this type of languages, P is not equal to R, P is equal to R, P is equal to 2R, P is not equal to 2R. This type of languages are always DCFL. Yes or no? Okay, so you do not have to create DPDA. If you did not understand this DPDA, very good, no problem, no problem. Do not worry about it. Okay, just move on. If you understood this DPDA, then also very good. Okay, so remember, this is our DCFL. So finally, which statement is correct? Tell me. The question is asking which statement is false. So you can see that L2 is context free. This statement is actually true, because every DCFL language is CFL. So this statement is actually true. Okay, what about the next? That is L1 intersection L2. We will see. Okay, L1 intersection L2, we will see after some time. But you tell me about the remaining. The complement of L2. Remember, L2 is a DCFL. Yes or no? Remember, L2 is DCFL. So the complement of DCFL is what? The complement of DCFL is DCFL. Every DCFL is a recursive. Every DCFL is recursive. So remember, I can say that complement of L2 is recursive. This statement is also true. Okay, do you agree? This statement is also true. What about the last statement? Complement of L1 is context free but not regular. See, this L1 is regular, so its complement also will be regular. Yes or no? L1 is regular, So its complement also will be regular. The complement of regular language is regular. If you have a regular language, then the complement also will be regular. So option D is actually false. Option D is false. The question is asking which statement is false. So answer will be option D. But let's check option B also. Okay, so let me check about option B. Here you can see that L1 is given to you, that is 0 power P 1 power, basically that is 0 star 1 star 0 star. Yes or no? 0 star 1 star 0 star. This is your L1. And what was L2? L2 was 0 power P 1 power Q 0 power R, where P is not equal to R. Okay, so I can write it 0 star 0 power P 1 star. Okay, like this I can write. Yes or no? Here you can easily see that here P comma R, they are greater than equal to 0. Okay, now you tell me what will be their intersection. What are the common part? What strings are common? Here you can notice the template is same. Yes or no? 0 1 0 0 1 0, the template is same. So let's see the common string. The common strings will have this template. 0 1 0 means after zeros ones are coming, after one zeros are coming. Here also after zeros ones are coming, after one zeros are coming. So remember the template, the intersection, the common strings, because this means common strings. So the common strings will have this template 0 1 0. Now you tell me the common strings should have these strings, they must belong to L1 also, and they must belong to L2 also. Now notice L1 has no problem. Okay, you can put any power, L1 has no problem. Is this clear? Because in the L1 you can put any power, there is no problem. Okay, but you can easily see that L2 has a problem. Yes or no? Okay, L2 has a problem. So in the L2 you can notice that this and they must be different. So basically I can say that this P and this R, they must be different. Okay, they must be different, because remember these common strings, they belong to L2. So I can say this P must be different from R. Yes or no? And this can be anything. So finally I can say L1 intersection L2 is basically L2. Okay, do you agree? Okay, yes or no? So remember we found that L1 intersection L2 is basically L2, is basically L2. If you notice here, L2 is actually subset of L1. Okay, here one thing's easily you can notice that L2 is basically subset of L1. Like this is your L2 and this is actually proper subset of L1. This is proper subset of L1. That is the reason L1 intersection L2 is what? That is a L2. I hope you got it. Okay, that is the reason. Remember, that is the reason L1 intersection L2 is equal to L2. Okay, so that's it. So finally here, remember in this I can say that L1 intersection L2, that is actually L2. Okay, so you can write it here that L1 intersection L2 is L2, and L2 we have already seen that L2 is DCFL, so L2 is CFL also. Okay, so finally I can say this statement is actually true. Option B is true. The question is asking which statement is false, so answer will be option D only. Okay, is this clear? For this question only answer will be option D. I hope you understood. Let me tell you one more thing here actually, that is, see, all these type of languages are actually DCFL. In our DCFL identification lecture we have already seen, but let me quickly tell you that all these languages, for example, if you have, let's assume you have this type of template, a power m, b power n. Okay, where m comma n, they have some range. Okay, they are greater than equal to 0 or 1, doesn't matter. Okay, they are greater than equal to 0 or they are greater than equal to 1 or whatever. Okay, so this is your, let's assume this is your template. Okay, m comma n, they can be anything. This is what I'm saying, m comma n, they can be anything. They can be greater than equal to 0, they can be greater than equal to 10. Okay, whatever. So you can see in this, let me tell you, if I ask you, for example, m equal to n, if I ask you m not equal to n, if I ask you m greater than n, if I ask you m less than n. Okay, is this clear? If I ask you m is equal to 2n, if I ask you m is not equal to 2n, if I ask you m is equal to 2n plus 1, if I ask you m is not equal to 2n plus 1. Okay, I hope you are getting the point what I am saying. Okay, so all these variations, for example, if I ask you m is less than 2n, m is greater than 2n. Okay, basically all these type of variations, they are DCFL. All these type of variations, they are DCFL, all of them. Okay, all of them, they are DCFL. Okay. Also remember that DCFL complement is DCFL. Yes or no? DCFL complement, that is also DCFL. Okay. So very easily you can see that all these templates, these are the templates, these are the standard templates of DCFL. All these languages are DCFL. Okay. But remember, for example, see, if I give you this language like a power m, a power n, b power n. Okay, if I say n is greater than equal to 1 or n is greater than equal to 0, then this is DCFL, this is fine. Yes or no? Now this is DCFL, that is fine. Do you agree? Okay, so here you can see. But remember, if I say that m, okay, you have a power n, b power n, and if I say n is prime, now tell me, is this language DCFL? Let me know. Now, is this language DCFL? Now remember, n is prime number. Okay, so that is actually not even CFL. This is not even CFL. This becomes CSL. Yes or no? This is not even CFL. This becomes CSL. Okay, I hope you are getting the point. Okay, is this clear? And remember one more thing, one more standard language. For example, a power m, b power n. Okay, this is your language, and let's assume the condition is given to you, that is like this, that n is greater than equal to m but less than equal to twice of m. This template we have already seen, if you remember. Okay, this language, this is not DCFL. Yes or no? This is not DCFL because there is a confusion. For every a, how many a should I push? Yes or no? Okay, so you can see this is not DCFL. Actually, this is CFL. Using non-determinism, PDA can do this. PDA can recognize this language using non-determinism, but this is not DCFL. Okay. Anyway, the point is very simple, that we have already seen in our DCFL identification lecture that which languages are DCFL, which languages are not DCFL. So you can see this language, you can see this language we have already seen in the previous lectures, that this is not DCFL, but this is CFL. Okay. So I hope you understood. So this is the complete analysis of this GATE 2013 question. I hope you understood. Okay, let's move on now. Let's solve this GATE 2014 question. So three languages are given to you, L1, L2, L3. The question is saying what is WR? That is the reverse of string W. Okay. Next you can see the alphabet is 0, 1, C. This is the alphabet. Which of the following languages, which of these languages are deterministic context-free languages? The question is asking which of them is DCFL. Okay, any language for which you can create DPDA, that will be DCFL. Yes or no? So let's see what about these languages. Let's see the first one, L1. L1 is saying 0 power n, 1 power n, where n is greater than equal to 0. 0 power n, 1 power n is greater than equal to 0. This is a standard example of DCFL. Yes or no? Whenever we study DCFL, then the first language we consider is 0 power n, 1 power n. Okay, so this language is DCFL. You can easily create the DPDA. Tell me what will be the DPDA? In the DPDA, for every 0, you will push 0, and for every 1, you will pop 0. Yes or no? So for this, actually, I can create DPDA. The DPDA will be like this. This is the push state. In the push state, what I will do? For every 0, for every 0, without looking at the stack, don't look at the stack, don't pop anything, don't read anything from the stack. Yes or no? Okay, you will push 0. Yes or no? Very simple. So remember, without popping anything from the stack, this means there is no pop. We are not popping anything from the stack, and this means we are pushing 0 in the stack. So you can see for every 0 we will push 0. Then when this 1 comes, then what we will do? Then this 0 we will pop. Okay, this is the pop state. In this pop state, you can see for every 1 we will pop 0. In the DPD, I told you that there is a end marker symbol. Yes or no? So remember, okay, if you have this type of string like 000, 111, then you know that there is a end marker symbol. Okay, in the DPDA, we have string end marker symbol, which will tell you that string has ended. So this is a special symbol to tell you that string has ended. Okay, so you can notice in this state, if end marker comes, then your top of the stack must have Z. Yes or no? Then I will go to the final state. Very simple point. Okay, one corner case is remaining here. If you put n equal to 0, then empty string, basically that should be accepted. Yes or no? Okay, yes or no? Empty string should be accepted. Okay, so if you have empty string, then basically I can write like this. This I can write, this I can write because there is end marker. So I can simply write it that directly end marker is coming. Okay, so you can see in the initial state, if the first symbol itself is end marker, if the first symbol itself is end marker, first symbol is end marker, and on top of the stack there is Z, then I will go to final state. Now you can see this is the DPDA for this language L1. This DPDA is also accepting the empty string also, because if you put n equal to 0, then empty string belongs to the language L1. So that is the reason I can say this is the DPDA. So this language is what? This language is actually DCFL. Yes or no? Okay, very simple. Let's see the language L2, that is WCW reverse, where W belongs to 0 1 whole star. Okay, the language L2, this is a W, then C, then W reverse. Remember, W does not contain C. W actually belongs to 0 1 whole star. Okay, here remember your alphabet is what? Your alphabet is 0 1 C. This is the alphabet 0 1 C. But here you can notice that the W does not contain C. Okay, W does not contain C. W does not contain the symbol C. So here you can notice, can DPDA find the middle symbol? Let me know. Is it possible that DPDA can find the middle symbol? Yes, because this symbol C will tell you that I am the middle. Okay, yes or no? You already know that length of W is always equal to length of W reverse. Okay, so in this L2, every string, if you notice, that is like this, that there is string W, then this symbol C, and then there is W reverse. Okay, for example, if your W is, let's assume, remember W belongs to 0 1 whole star, so W does not contain C. W does not contain C. Okay, here if your W is like this, then W reverse will be what? W reverse will be 10010. Okay, so here you can notice this symbol C is telling you that I am the middle symbol. Yes or no? Here this symbol C indicates middle symbol. This C will tell you that I am the middle symbol. Now there is no problem. Now we can easily create the DPDA. What we will do, remember? Okay, this W we will push. For 0 we will push 0. For 1 we will push 1. So this W we will push. And then this C we will skip. Okay, this C we will skip. So remember, I can create DPDA. For this language L2, I can create DPDA. DPDA is possible. Okay, because you can easily find the DPDA exist. Okay, yes or no? Because you can easily find the middle symbol. Because this symbol C will tell you that I am the middle symbol. So you can see before this symbol C, I will push everything. If 0 comes, I will push 0. If 1 comes, I will push 1. Okay, when the symbol C comes, then I know that this is the middle symbol. So this symbol C, I will skip. Okay, then after that, what I will do? After that, it is very simple. For 0, I will pop 0. Yes or no? You can notice. For 0, I will pop 0. Okay, look at, for 1 I will pop 1, for 0 I will pop 0, for 0 I will pop 0. Okay, so you can see this is what I'm going to do, that after this symbol C I will start popping. For 0 I will pop 0, for 1 I will pop 1. And then when the end marker comes, in the DPDA we have end marker facility. So when this end marker comes, then what should happen? Then your top of the stack must have Z. Okay, yes or no? This should be there in your stack memory. Your top of the stack must have Z. Then this string will be accepted. Otherwise, this string will be rejected. Okay, so that's it. So you can see for this language we have DPDS. So this language is DCFL. Okay, is this clear? So this language is also DCFL. You can see this option, this language L2, this is also DCFL. What about L3? L3 is saying WW reverse, where W is a binary string. Now this language is not DCFL. We have already seen this many times. In the previous lecture also we have seen. In the DCFL, CFL identification also we have seen this, that this is not DCFL. Why this is not DCFL? Because here we cannot find the middle. I told you DPDA cannot find the middle. Yes or no? This is your L3, this is WW reverse. Okay, so here W is a binary string. Here you can notice that W belongs to 0 1 whole star. Here actually the problem is that DPDA cannot find the middle symbol. Okay, DPDA is deterministic. So if you give some string, if you are giving some string, for example, okay, let's assume some string you are giving. Now, if this is the unknown part, now I don't know where the middle symbol will be. Will it be here? Will it be here? Will it be here? Okay, so the point is that the DPDA cannot find the middle symbol. That is the problem. Okay, so let me tell you here that DPDA can't find middle. DPDA cannot find the middle symbol. So that is the reason I can say this language is not DCFL, because DPDA cannot find out what are the middle symbol. Remember in L2, this symbol C is telling you that I am the middle. Understand the difference between L2 and L3. In L3, there is no symbol which will tell you that I am the middle. Yes or no? In L3, there is no symbol because W belongs to 0 1 whole star. There is no symbol which will tell you I am the middle. So here the DPDA cannot find the middle. But remember, sorry, in L3 DPDA cannot find the middle. But remember in L2 you can see this symbol C is telling you, because W does not contain C. Okay, you can see that W does not contain C. W belongs to 0 1 whole star. So that is the reason this symbol C is telling you that I am the middle. Okay, yes or no? This symbol C indicates that I am the middle symbol. So that is the reason. Remember, this language is not DCFL. Okay, but this language is a, but this L2 is a DCFL. The question is asking which is DCFL. So finally the answer will be that L2, L1, these are DCFL. Answer will be option C. Is this clear? Remember, this L3 is actually CFL. Okay, all these languages are CFL. This palindrome, this is even length palindrome, WW reverse. This is actually CFL, that you already know. Yes or no? This language L3, that is WW reverse, where W belongs to 0, 1, whole star. Okay, this is your even length palindromes. Even length palindromes, reverse matching. Okay, so this is actually CFL. What you can do, for this language, you can easily write the context free grammar. Okay, there is a standard context free grammar for this language that will be like this, that if your first symbol is A, last symbol must be A, in between you can put any even length palindrome. If the first symbol is B, last symbol must be, in between you can put any even length palindrome. Okay, also epsilon is also even length palindrome. This is the context free grammar for this language. So that is the reason I can say this language is a CFL. Okay, because there is context free grammar, so I can say L3 is a CFL. Very simple. Okay, remember in this L3, in this even length palindromes here, the PDA can find the middle symbol using non-determinism. In the PDA, in the push down automata, there is non-determinism. So using non-determinism, we can find the middle symbol. I told you one thing, that for PDA, finding the middle symbol is never a problem, because PDA has non-determinism. So finding the middle symbol is never a problem for PDA. Okay, so what your PDA will do, non-deterministically it will find the middle symbol. So very simple, it will push it and it will pop. Okay, so very simple. So this PDA can do, PDA can recognize L3, so L3 is CFL. So this question we have seen, only L1, L2 are DCFL. Let's all get 2022 question. Two languages are given to you, L1, L2. First, let's see what is the language L1. The language L1 is A power n, W A power n, where W is AB whole star. See, A power n, W A power n, where the question is saying that W belongs to AB whole star. Okay, in the question, if you notice, the range of n is not given to you. So tell me what is the range of n? Here in the language L1, W is AB whole star. W is a binary string, but the range of n, this variable n, the range of n is not given. So what is the range of n? I told you in theory of computation, whenever range of a variable, range of a power variable is not given, then always you take it greater than equal to 0. Yes or no? Is this clear? I told you in the Ullmann book this is given. Okay, if you study the Ullmann book for TOC, then in this it is given that for any variable, for any power variable, okay, for any variable in power, for example m comma n, like okay, a power m, b power n, then if range is not given, then remember by default the range is always greater than equal to 0. Okay, in theory of computation subject. So this is the by default range. Okay, now let's see here. So n is greater than equal to 0. Now you tell me, first you understand this language, then you answer the question. Here you tell me one thing. See, some students, what they will be thinking, they will be thinking there is comparison here. Many students, they what they will do, they will not understand the language. Without understanding the language, they will answer this question. They will see that okay, there is comparison. There is comparison, a power n, a power n. There is comparison. Because there is comparison, so this is not regular. So L1 is non-regular. This is what many students do. Okay, they do not understand the given language. They do not understand which strings belong to the language, which strings do not belong to the language. They just by heart the concept that okay, there is a power n, there is a power n, so there is comparison, so the language is non-regular. So this is called rote learning. Okay, and let me tell you, this is nonsense and this is wrong. Okay, this is called rote learning. Basically, you are not understanding the language, you are not applying the logic here. Okay, you are rote learning that okay, there is comparison, so it will be non-regular. This is wrong. Okay, first you understand the language, what strings belong to L1, which strings do not belong to L1. So first you understand that. Okay, now you notice here you can notice one thing. Some questions I'm asking you and you tell me the answer. Tell me this string, a string I'm giving you, and you tell me this string belongs to the language or not. For example, if I give you a power 2, then there is this w belongs to ab whole star. So okay, remember I am giving you this string a power 2, then b a, okay, this string, and then maybe b and then a power 3. Okay, tell me this string will belong to the language or not? Let me know. A very simple question. This string will belong to the language or not? Will it belong to L1 or will it not belong to L1? The answer is yes, this will belong to L1. Yes, this string will belong to L1 because remember, this string I can write in this format where n is greater than equal to 0 and w is binary string. Okay, see, some students are thinking that this is a power 2, this is a power 3, so they are different, so this does not belong to the language. Array, who told you to consider this as n? Who told you to consider this as a power 2? You can consider the entire string as w. Yes or no? Okay, I'm using the different color. It does not mean that this is w. It does not mean. I'm using the different color just to confuse you. Okay, is this clear? So remember here actually what you can do. Here the entire string you can consider as w, or what you can do. Notice here are these are the possibility. For example, here what I can do, I can consider like this a power 1, and here also a power 1, and in between whatever I have, that I can consider as w. This whole thing I can consider as w. Do you agree with me? So now you can notice this is the template. So this string belongs to the language. Yes or no? Here you can notice I can consider this a b double a b a double a b double a b double a. This I can consider as w. Now also you can notice this belongs to L1. Or what you can do in a very simple way, what I can do, I can consider the entire string as w. This entire string I can consider as w. Okay, take this entire string as w and take this n equal to 0, because n is greater than 0, n is greater than equal to 0. So I can just take this n equal to 0. If I take n equal to 0, then it will be like epsilon epsilon. Okay, now also you can see this string will belong to the language. I hope you are getting the point. So remember, actually every string will belong to the language. Okay, if you understand this language, here what will happen? Here every string will belong to the language, because remember, so this L1 is basically sigma star. Why this L1 is sigma star? Because whatever string you take, the entire string you can consider as w. See, whatever string you take, whatever string y you take. Okay, for example, let's assume this string you take. Now what you can do, this entire string you can consider as w, and you can take n equal to 0. Okay, so this entire string, whatever string y you take, this y I can write like this, that a power 0, then there is y, and then there is a power 0. Okay, and this y I am considering as w. So you can easily see that this language is basically sigma star, and sigma star is what? That is regular. Okay, sigma star is what? That is regular. Is this clear? So whenever some language is given to you, first you understand the language, which strings belong to the language, which strings do not belong to the language, then you answer the question. So here actually L1 is regular. One more thing, if you take any range, for example, if you take n greater than equal to 1, then also it will be regular. Yes or no? See, if you take n greater than equal to 1, then also this language will be regular. Okay, now what will happen? Now basically what you can do, now the regular expression will be, now this language will be like this, that there is a power 1, there is a power 1, and in between you can put any string w. Okay, is this clear? Basically what I am saying, I am saying that if you take n greater than equal to 1, then what you can do, whatever string you take. Okay, now whatever string you take, now whatever string you take, you can consider n equal to 1. Okay, you can consider n equal to 1, and the remaining string will be w. The remaining you can consider as w. Is this point clear? Okay, for example, if I give you this string, consider this string like a power 3. Okay, then I have something like b double a b, and then a power 5. Okay, then in this situation, will it belong to the language or not? Yes, this will belong to L1. Why? What is the reason? The reason is very simple. What I will do, I can rewrite this string. Look at this string. Look at this string. I can rewrite this string y like this. This string I can rewrite like this, that I can write like a power 1. Okay, a power 1, a power 1, and in between whatever I have, that I can consider as w. Okay, in between whatever I have, that can be considered as w. This I can consider as w. So you can easily see this language is also regular. Yes or no? This is also regular because anyway, what this language, this is a, then in between you can put any a or b whole star and then ending with a. Yes or no? You can see this is the regular expression, so the language is also regular. This is the regular expression, and if you have regular expression, then the language will be what? Then the language will be regular. Okay, I hope you understood. The same thing will happen if you consider n greater than equal to 2, then also the same thing will happen, no problem. Okay, if you consider n greater than equal to 2, then your L1 I can write like this: a power 2, a power 2, and in between you can put a or b whole star. Okay, still this language is a regular. But remember, let me tell you, when the range is not given, then you always have to consider n greater than equal to 0. Okay, is this clear? So here in this question, actually, the range of n is not given, so always consider this as greater than equal to 0. This is the variable in power. This is the variable in power. So by default, n is greater than equal to 0. This is the by default situation. Okay, so you can easily see this language is actually regular. Okay, this type of more variations are possible. For example, let me give you one more variation so that you can appreciate the beauty of this type of questions. For example, if I give you, consider this language L equal to 0, a power n, a power n. Okay, where n is greater than equal to 0. Tell me, is this language regular or not? A power n, a power n. So can I say there is a comparison here, that there is a power n, there is a power n, there is a comparison, so it is non-regular? Yes or no? Some students, they can think like this, that there is a power n, there is a power n, there is comparison, so this is non-regular. But actually you understand the language first. This I can rewrite as a power 2n, where n is greater than equal to 0. Now this is your a power e1. Now this is just simply a power e1, and this is a regular language. Okay, I can write the regular expression very easily. This is the regular expression a whole star. So like this. So remember, before answering any question, first you understand the given language, which strings belong to the language, which strings do not belong to the language. Okay, tell me about L2. In this question, what about L2? The L2 is wx w reverse, where w comma x both are belonging to ab whole star, and wx, the length is greater than 0. Okay, so let me see this L2 also. What is this L2? The language L2 is like this: wx, then there is w reverse, wx, then there is w reverse, and the question is saying that wx, they both belonging to ab whole star. Okay, and the question is saying that length of w and length of x, they are basically greater than 0. Okay, they are basically greater than 0. Now let's see this. Let's solve this question. So here one thing you notice, here one thing you can easily notice, that this language is definitely CFL. Okay, why this language is CFL? Because you can easily see there is w reverse, and there is in between you have some x which is a comma b whole star. Okay, where length is greater than 0. So actually let me tell you, this language, for this language I can easily create the context free grammar. Okay, see, we will see whether this is regular or not, that we will discuss after some time. But let me tell you that this language definitely, this language is CFL. Why? Because I can easily write the context free grammar. Here what is happening here, you can see this is the recursive structure. For recursive structures, we can easily write the context free grammar. Here basically there is recursive structure. Okay, and between you have in between recursive structure there is something. So what I can do, I can write the context free grammar like this: there is w, there is x, there is w reverse. What I will do, notice, this x I can generate using some variable a. Using some variable a, I will generate this x, and this w reverse, this w reverse I can generate using the variable, the start variable s. Okay, using the start variable s, I can generate the wx, w reverse. Okay, so this will happen. Remember, this w reverse I am generating using the variable s. So it will happen like this: if the first symbol is a, then the last symbol must be a. If the first symbol is b, the last symbol must be b. Okay, yes or no? So you can easily see, because w reverse I am generating with the variable s. Okay, then finally you can notice that in between this s can go to a. Yes or no? But remember one thing, the length of W is greater than 0. The length of W, this length of W is greater than 0. Okay, so instead of sending this as to A, this S, instead of sending this as to A, because W is non-empty. Okay, W is non-empty. I can say length of W is basically greater than equal to 1. So instead of sending this as to A, I will send like this AAA or BAA, BAB. Okay, AAA or BAB. Like this, I will send. I hope you understood. Because remember, the length of W is greater than equal to 1. That is the reason. Okay, the W cannot be empty. The point is W cannot be empty. So what I will do, remember, this as instead of sending to A, I will send it to AAA or BAB. Okay, now this A will generate what? Now this A will generate X. Okay, so using this A, I will generate X. Remember, the length of X is also greater than 0. So it will happen like this. And remember this X, basically what is this X? Okay, from here you can easily see what is this X. This X is basically sigma plus. Yes or no? Because X cannot be empty. Okay, remember X belongs to AB whole star. So from this variable A, I will generate X. Sigma plus I will generate. Okay, so that is very simple to generate. What I will do? A can go to AA, or it can go to BA. A can go to AA, or it can go to BA, or it can go to A, or it can go to B. Okay, so like this. That's it. That's it. This is the context free grammar that I will get. Because there is context free grammar, so this language will be what? So this language will be CFL. Is this point clear? Please tell me. Very simple, right? Yes or no? I hope you understood. So remember, this is the context free grammar I can write. Because remember, what is X? X is anything. X is basically sigma plus, because length of X is greater than 0. So you can do that. You can generate sigma plus here. So because I can write context free grammar for this language, so this language is what? This is a CFL. Okay. So we have seen this is regular. We have seen this is regular. We have seen this is CFL. So if this is MCQ question, actually this is MSQ question, let me tell you. Actually this is MSQ question, but which option is definitely correct? But which option is definitely correct? See, tell me. Here you can easily see that L1 regular, L2 CFL. This option is definitely correct. Yes or no? Actually this is MSQ question. Both are CFL. That is also correct. Okay. And this option is definitely wrong. This option is definitely wrong. Now let's check whether L2 is regular or not. That is what we need to check. This L2, is it regular or not? Now let me check, is this L2 regular or not? So this language L2 is given to you where W, X, they both have length greater than 0. Okay. So let's see. Here basically we have to check whether this X will cover W or not. Sometimes what can happen? This X can cover W. This type of possibilities are there where X can cover W or W can cover X. This type of possibilities are there. Here let's check whether X can cover W or not. Okay. This type of possibility can exist or not. So here you consider one scenario. Okay, see, if the first symbol is 0, then definitely last symbol will be 0. Do you agree? Okay, remember the length of W is basically greater than 0. Means the length of W is greater than equal to 1. Okay, so whatever W I take, notice one thing. If I take any W, for example, let's assume you take this W. Okay, this is the W that I am taking. Now, you tell me a simple point. If this is the W I am taking, AB, double AB, then what will be the last symbol? If this is the W I am taking, some X I am taking, okay, then W reverse. If this is the W I am taking, then some X I am taking, then there will be W reverse. W reverse will be what? That will be B A A B A. Okay, just focus one thing here. Here, if the first symbol is A, then the last symbol must be A or not? Do you agree? Because I have W reverse. If the first symbol is A, do you agree that last symbol will be A? Because first I have W, then I have W reverse. Okay, please focus here. Initially I have W, and then at the end I have W reverse. So you tell me, if the first symbol is A, last symbol must be A. So actually what I can do, notice here, instead of considering this as W, I can consider the first symbol as W. The entire thing I can consider as X. Okay, the entire thing I can consider as X. And the last symbol I can consider as W reverse. I hope you are getting my point, what I'm saying. Here basically X is covering W. This is what I'm saying. Okay, are you getting my point? Basically, you can see that if the first symbol is A, then the last symbol will be A. Okay, that is the reason I can consider w as the a and w reverse will be a. Okay, the entire string will I will consider as x, because the length of x, that is basically greater than 0. And remember, x can be anything. X can be anything. Okay, I hope you are getting the point. See, very simple point. Whatever w you take, okay, whatever w you take, then you have w, there is w, then there is x, then there is w reverse. Initially you have w, then you have w reverse. See, whatever w I take, one thing is guaranteed. What is that? That if you start with a, then definitely you will end with a. So what I can do, I can just consider this a as w, and I can consider this as w reverse. If you start with a, then you will end with a. Okay, in between whatever comes, I will consider this entire thing as x. Or what can happen? Or what can happen? Or you can start with b, and if you start with b, then you will end with b. Yes or no? If I start with b, then definitely I will end with b, because remember, initially I have w, then I have w reverse. So remember, whatever w I take which is starting with b, then I will end with b. So what I can do, I can just consider this b as w, and this I can consider w reverse. In between whatever is coming, that I will consider as x. But remember, the length of x, that is greater than 0. Okay, so finally what will be my regular expression? So this language L2, this language L2 was like this: wx w reverse, where w comma x, they are any strings. They can be any strings, but the condition is there that both have length greater than equal to 1. They both have length greater than equal to 1. So here you can easily see in this L2, I have this type of strings, that if you start with a, then in between you can put anything x. Okay, but remember, x is sigma plus. Yes or no? X is sigma plus. X length is greater than equal to 1. So I can say x is basically sigma plus. Okay, here you can see that x belongs to ab whole star, but x length is greater than equal to 1. So you can see, if the first symbol is a, then the last symbol must be a. Yes or no? Okay, so this type of string are there. Or, okay, or either I have this type of strings, or I have this type of string where the first symbol is b, the last symbol is b. In between, I can put x which is sigma plus. Sorry, sigma plus. X which is sigma plus. Okay, so finally I can say this language L2, I can represent this language L2 using a regular expression. The regular expression will be like this: a, then a or b whole plus, then a, or or b, then a or b whole plus, then b. Okay, is this clear? So this is the regular expression, and because this L2 has a regular expression, so this L2 becomes what? L2 has regular expression, so this L2 becomes what? This becomes a regular language. Yes or no? This L2 becomes a regular language. So I hope you understood. So finally, I can say both are regular. Yes, this statement is also true. Okay, so the answer for this question will be what? This is a MCQ question. Which statements are true? A, B, C. These statements are true. Okay, very simple question, right? But you have to understand the given language. You understand, then you answer the question. Okay. Let me tell you one more thing here. Actually, this question was there in the Go classes test series also. Okay, this question actually, this first option, okay, option L1, this you can find in the Go classes test series also. And let me tell you, we did not put this question from the gate. Okay, basically this question is already present. This L1 actually, it is already present in many standard resources, and from those standard resources we took this L1 and we put in the Go classes test series, and it was a coincidence that this also came in the gate exam. Okay, so anyway, this type of many tricky questions are present in the Go classes test series, so that you can practice and with improvement, because you will make some mistake and then you will improve. Okay, you will understand what is the mistake, then you will improve yourself, and then in the gate exam, in the actual gate exam, you will not make the mistake. Okay, so many these type of tricky languages are present in the Go classes test series, in the Go classes weekly quizzes. You can check it out. Okay, now let's move on. Let's solve this gate 2020 question. Consider the following languages L1, L2 are given to you. Okay, here let's see this language L1. This is WXYX, where WXY, they belong to 0 or 1 whole plus. Okay, let's see. The first language L1 that is given to you, that is WXYX, where W comma x, both they belong to wxy, all of them they belong to whom? wxy, all of them they belong to 0 or 1 whole plus. Okay, so this is the idea. Now let's see whether this language is a CFL or not. The question is asking, is this regular, is this CFL? Okay, so first we have to check regular or not. Okay, so this language, is it regular? Let's consider this. See, the question is saying that w comma x comma y, they belong to 0 or 1 whole plus, yes or no? Okay, but here you can notice there is something interesting, that is there is x here and there is x here. Okay, so it is looking like a not regular language, yes or no? You might be thinking, sir, that there is x here, we have to compare this x with this x, so there is a forward matching, yes or no? There is a forward matching. Okay, because see, this w I can ignore. Okay, whatever w I have, I can ignore. Then there is x, then there is x, then y I can ignore, then there should be another x. So you can see there is a forward matching here. Okay, if I have this string, for example 0110, okay, then the same string should be here. Okay, now you can notice that there is a forward matching. So this is not CFL, yes or no? This type of language where you have forward matching, so this type of languages are not CFL. You might be thinking like this, yes or no? Many students, they will think like this, but this is actually wrong. Okay, let me tell you, this is also wrong. Why this is wrong? Why this is wrong? Let me explain. Because first you understand the language. Okay, always first you understand the language. You check, is it possible that w can cover x? Is it possible y can cover x? Is it possible x can cover w? Basically you check w, x, y, three things are there. There are three people. Okay, maybe one of them can cover the other. Maybe two of them can cover x. Maybe x can cover w, y. Basically you have to check. I am saying that you should check, can w cover x? Can y cover x? Can w comma y they cover x? Okay, or or x cover y. Basically you have to check. This is what I'm suggesting. Okay, now in the previous lecture also this type of languages we have seen, and there are many tricky languages we have seen, and similarly you can do the analysis of this language. Basically here, very interesting thing you can notice here. Okay, it is not a hard thing. See, whatever w I take, just consider like this. See, w can be whatever, I don't care, because remember there is no comparison with w, yes or no? W x y x, there is no comparison with w, so w can be whatever, I don't care. Y can be whatever, I don't care, yes or no? Because there is no comparison with y. Now the interesting part is x. Okay, there is x and there is x. Okay, so if your x is, for example, this is your x, then the same x should come here. Okay, now you notice this x is at the end and this x here is here. One thing you notice, one thing, instead of considering this entire string as x, instead of considering this entire thing as x, what you can do, you can just consider the last symbol, because this x is at the end. Okay, I hope you are getting the point that this x is at the end of the string. Okay, this is your entire string, at the end you have this x. So instead of considering this entire thing as x, instead of considering this entire thing as x, what you can do, you can just consider this last symbol as x. Okay, again very simple point. What you can do, notice, I am saying that, this is w, then okay, then there is something, then there is something, then there is something, there are four parts. I am saying that instead of considering this entire thing as x, just this last symbol you can consider as x. Okay, this last symbol, just consider this last symbol as x. Okay, so this x will come here, and now the remaining part you can consider as y, w comma y. Okay, yes or no? Similarly, if the last symbol is 0, if the last symbol is 0, then what you can do, you can consider the last symbol. If the last symbol is 0, you can consider this as x. Okay, and the remaining thing you can consider w comma y. Yes or no? You can consider w comma y. Now you notice one thing, here we are considering all the possibilities. Okay, here we are considering all the possibility. Why? What is the reason? Because you notice, see, if you say that, sir, we are not considering all the possibility. If x is like this, for example, let's assume x is like this. Okay, maybe x is this. See, if you say that, okay, this is x, then this same x should repeat here. If you say this is x, then what I will say, don't take this entire thing as x. what you can do, because this as it is will appear here because xx. So instead of considering this entire thing as x, what you can do, just this last symbol you consider as x. Okay, this last symbol you consider as x. So this will be your x. Now the remaining thing, okay, now the remaining thing you can consider, this remaining thing is basically you can consider as w. Okay, and this remaining thing you can consider as y. Okay, I hope you understood. So finally, what will be the answer? So remember this language that is given to you, this L1, that was WXYX. Okay, where WXY, these three people, they belong to A comma A comma B whole plus. Okay, 0 comma 1 whole plus. 0 comma 1 whole plus. Okay, so what I can do here, you can easily see the last symbol I can consider as a x. Is this clear? So this language actually I can represent like this, that for this language I can say the last symbol I will consider as x. Somewhere there should be x. Yes or no? If the last symbol I consider as x, somewhere there should be x. Okay. Now this part I will consider as w, this part I will consider as y. But remember, they must be sigma plus. Yes or no? So I can say this is also sigma plus, this is also sigma plus. Okay, is this point clear? This is also sigma plus, this is also sigma plus, or or what can happen? If the last symbol is 1, then somewhere there should be 1, because remember, if you consider this as 1, then somewhere there should be 1. Somewhere there should be 1. Now this w is sigma plus, this y is sigma plus. This w is sigma plus, this y is sigma plus. Okay, so your final answer will be this L1 I can represent using the regular expression that will be like this: 0 or 1 whole plus 0, then 0 or 1 whole plus, then 0, or or 0 or 1 whole plus 1, 0 or 1 whole plus 1. Okay, this is the regular expression for L1. And because I can write regular expression, so what L1 will become? So what L1 will become? L1 will become regular. Yes or no? Very easily you can see that L1, this has become regular. I hope you understood. Okay, very simple. Let's see what about L2. L2 is saying xy, where the length is same but they are different. Okay, length is same but they are different. Actually, this is similar to your WW complement. If you remember, this is similar to your WW complement. Okay, do you remember? I told you this WW. Okay, this note we have already seen in our lectures, that if your W is a binary string like 0 1 whole star, if this is your W, then in that case we have seen this result. This is a standard result, that in this situation WW, this language is not CFL. Okay, because there is a forward matching. There is a forward matching. So that is the reason the PDA cannot recognize this. So this is not CFL, but we have seen WW complement is CFL. Yes or no? We have seen WW complement is a CFL. Do you agree? Okay. So this is what we have seen, that WW is not CFL, but WW complement is CFL. Okay. And similarly, this L2 is actually standard language. This is similar to your WW complement. Actually, what I'm saying, see, this WW complement is CFL. What is the reason? The reason is very simple. Here, there is mismatching. You need to do the mismatching. Okay. That the first half and the second half, they should mismatch. Yes or no? Okay. So that mismatching you need to do. So that we can do using the PDA. This we have seen in our CFL identification lecture. You can watch identification of CFL lecture. The link you can find in the pinned comment in the description. Okay. There I have discussed this result. This is a standard result. Okay, so WW, that is not CFL, but WW complement is CFL. And what about this L2? This L2, if you notice, this L2 language is given to you like this, that here you have XY. The question is saying that their length is same. The question is saying that their length is same and X is not equal to Y. Their length is same and X is not equal to Y. Okay. Now you notice here, few things you notice here. If I say X is equal to Y, okay, if I say X is equal to Y, okay, if I say X is equal to Y, now length is same and X is equal to Y. So in this situation, you can see this becomes your WW. Yes or no? Because x is same as y. Yes or no? X and y are same. So this becomes your WW. And because x comma y they belong to A or B whole star. Here you can notice x comma y they belong to A or B whole star. So they are binary strings. So this becomes your not CFL. Okay, so this will happen if you have x equal to y. But in this question, if you notice, there is x not equal to y. Okay, so when you have x not equal to y, then what will happen? When you have x not equal to y, here basically it should happen that first half, remember they are equal, length is equal. Okay, so in this, every string is like this. Every string you have like this, that this is the first half. That first half must not be same as second half. First half must not be, or your first half is x and your second half is y. Why? What the reason? What the reason the first half is x and the second half is y? Because their length is same. Yes or no? This is an important point, that their length is same. So that is the reason first half is x, second half is y. And we are saying that x is not equal to y. X is not equal to y. So basically, what should happen? If x is not equal to y, then what should happen? This string should mismatch with this string. Yes or no? Okay, at least one position should be there where there is a mismatching. Do you agree? Okay, means for example, let's assume here you have five positions. Let's assume here you have five positions. Then there should be, if x is not equal to y, that means there should be a position. For example, maybe the third position, or maybe the fourth position. Okay, maybe consider this fourth position here, and consider this fourth position here. If x is not equal to y, is this enough that there is a position which is mismatching? Please tell me, do you agree? Do you agree that if if x is not equal to y, then this entire x and entire y does not have to mismatch? Yes or no? One character mismatch is enough, if you remember. Okay, one character, like one position. Remember, the remaining position, they can be same or different, I don't care. The remaining position, they can be same or they can be different, I don't care. But you can see that one position should be there. For example, maybe fourth position or third position or first position, whatever. Basically, there should be at least one position where there is a mismatch. Now this is enough. Now what your PDA can do? Your PDA can find this one position with non-determinism. Using non-determinism, our PDA can find this one position, this single position, or I can say this one position where there is mismatch. This one position our PDA can find using non-determinism. Our PDA will use the non-determinism to find this one position where there is a mismatch. So that is the reason this language is a CFL. Okay, that is the reason this language is CFL. Now let me tell you, either you can watch the CFL identification lecture. In that lecture, I have discussed this language. Okay, so you can watch that lecture to understand that this is CFL. The link you can find in the description, also in the pinned comment, identification of CFLs. There you can watch it. Or you can just see that this is a standard result. Okay, you don't have to worry about this language because this is a standard language. Okay, there is a mismatching here. Basically, the first half, second half, they should not match. They should be different. And this language, this mismatching language, this is a standard example of CFL. Okay, I hope you understood. So remember, this is a, I can say this is a standard. This is a standard example of CFL. Okay, because here we are mismatching. We are mismatching. So finally, I can say the answer will be what? You can see L1 is regular and L2 is a CFL. Okay, let me tell you, L2 is CFL, L2 is not DCFL. Okay, let me tell you, L2 is not DCFL. Why? Because actually we need non-determinism. Okay, because in L2, what will happen? The PDA will use the non-determinism to find this mismatching position. Okay, in this L2, let me write it here. In this L2, what will happen? The PDA, okay, so let me tell you that in L2, you have this type of situation that there is first half is x and the second half is y. Okay, the length of x is equal to length of y. So this is the first half, second half. Now you can see, okay, let's assume there are five symbols in the first half. Okay, there are five symbols in the second half. Now you can see that, okay, there, if I want x is not equal to y, then one position is enough. Yes or no? Okay, maybe that position is maybe second position. Okay, maybe that position is second position. Remember, the remaining position, they can be mismatch or they can match. I don't care. In the remaining position, you can match or you can mismatch. I don't care. In the remaining position, you can have same symbol, you can have different symbol. I don't care. Okay, but the point is that there should be at least one position, and this at least one position is enough. Okay, so maybe there should be at least one position. So you can see second position where there should be mismatch. If there is A here, then there is B here. Okay, so now let me tell you, this position PDA will find using non-determinism. Okay, PDA uses non-determinism. PDA using non-determinism to find this one position, to find this one, to find the one to find one position, to find a position basically. Okay, to find a position. Okay, at least one position. So you can see that your PDA will use non-determinism to find a position in first half and second half. In first half and second half. In first half and second half, where mismatching is happening. Okay, is this clear? Where mismatch happens. Where mismatch happens. So very simple point. So remember what your PDA will do. It will use the non-determinism to find a position, at least one position, because at least one position is enough. The remaining positions, I don't care. Okay, the remaining positions, they can have same symbol, different symbol. I do not care. So at least one position I want. So what my PDA will do? It will use non-determinism to find a position in first half and second half where mismatch happens. So that is the reason. Remember, this L2 is not DCFL, but this L2 is a CFL. This is a context-free language. Okay, so let's see which option is correct. L1 is regular, L2 is CFL. Yes, option A is true. Okay, is this clear? So very simple. So for this question, the answer will be option A. Okay. Let's solve this question. This is GATE 2005 question. So two languages are given to you, L1, L2. The question is asking their intersection, their union, and they context free, context sensitive? So let's check. So first let's check L1. Is that context free? The language L1 is given to you, that is A power n, B power n, A power n, B power n, and there is C power m. Okay, and what is L2? The language L2. The language L2 is A power n, B power m, C power n, C power m. Okay, in both the languages, m comma n are greater than equal to 0. Sorry, greater than 0. Okay, in both the languages, this is the situation. Okay, now here you can easily see that both these languages are actually CFL. Yes or no? Because here only this is what we need to do, and here only this is what we need to do. Okay, do you agree? So basically, these languages. Okay, let me. Okay, so you can see here, actually this L1 I can write as A power n, B power n, C plus, because remember m comma n are greater than 0. Okay, consider this m comma n greater than 0. So this L2 I can write as A plus, then B power m, C power m. Okay, you can easily see these two languages are actually DCFL. Okay, yes or no? These are standard examples of DCFL languages. So DCFL, so they are CFL also. So both the languages are CFL also. Every DCFL is CFL. Okay, they are non-regular. Okay, you can see here what you will do here in this language. In this language, for every A, I will push one A, and for every B, I will pop one A, and this C I will ignore. Okay, here A I will ignore. For every B, I will push one B. For every C, I will pop one B. Okay, so you can see they are DCFL, DPDA. You can easily create the DPDA for these languages. These are standard examples of DCFL languages. So these are CFL also. Okay, is this clear? So I can say that L1, L2. For these two, I can say that they are CFL. Okay, this is what I can say, that L1 is CFL, L2 is CFL. So there is no problem so far. The question is asking which statement is false. So actually statement C, that they are CFL, this statement is actually true. So this is not the answer. Okay. Now let's see. What about L1 union L2? There is nothing to check, because remember CFL union CFL is always CFL. CFL union CFL, that is always CFL. Yes or no? So you can see that L1 union L2, that always will be CFL. The union of two CFL is always CFL. So this statement is also actually true. Okay. Now let's check intersection. Let me check intersection L1 intersection L2. So you find what are the intersection, the common strings. Okay, L1 intersection L2. So the intersection will ask you to give common string. So what are the common strings in L1 comma L2? Here you can notice one thing, that L1 has the same template as L2, because after A B are coming, after B C are coming. Here also after A B are coming, after B C are coming. So remember the template is same. After A B will come, after B C will come. Please understand the template is same. Yes or no? The template is after A B, after B C, after A B, after B C. So you can see the template is same. Now if you want the common string, means these strings they must belong to L1. If they must belong to L1, that then what should happen? In L1 we have this, that number of A should be equal to number of B. So remember these common strings, L1 intersection L2 means common strings. So these strings must belong to L1. So I can say that number of A must be equal to number of B. Now remember these are the common strings, so they must belong to L2. But in L2 we have number of B equal to number of C. Okay, you can see number of B equal to number of C. So number of B should be equal to number of C. Okay, finally I can say n greater than 0. Okay, look at this language, A power n, B power n, C power n. So remember here we got L1 intersection L2, that is A power n, B power n, C power n, where n greater than 0. This is the standard example of non-CFL. Yes or no? This language is not CFL, but yes, this language is CSL. This language is context sensitive language. Okay, so very easily you can see this L1 intersection L2, that is not context free. Why this is not context free language? This is a standard example of non context free language, because here you have to match number of A with number of B, number of B with number of C. But remember, when you match number of A with number of B, now at this moment there is nothing remaining to check with number of C. Okay, because after you match number of A with number of B, now we don't know, our stack does not contain the information related to number of A. Our stack does not contain information related to number of B. So you can see when you compare number of A with number of B, now after comparing number of A with number of B, our stack does not know how many A were there, how many B were there. So there is nothing remaining to check with number of C. That is the reason our PDA cannot recognize A power n, B power n, C power n. So this language is not context free, but yes, this language is context sensitive. So finally my answer will be, this intersection will be context sensitive, this statement is true. But the intersection is context free, this statement will be false. The question is asking which statement is false, so the answer will be option A. Okay, so like this you can do the GATE 2005 question. Okay, so I hope you understood everything so far in this session. Every question that we have taken, every GATE previous year question that we have discussed in this session, I hope you understood. I've given you the complete analysis of all the questions. In every question, whatever information you need to know, I told you. Okay, for every DCFL I have given you DPDA, for every CFL I have given you PDA or context free grammar. Okay, so the complete analysis of each question I have told you in this session. I hope you understood each and every GATE PYQ. Please share your feedback with me in the comments, it is very important. Okay, please always, whenever you are watching any video of Go classes on the YouTube, please share your feedback in the comments. It really means a lot. Okay, so thank you everyone. If you have any doubt, you can put your answer in the comments. You can put your doubt in the comments also. Okay, thank you.